good morning, everyone. So this is time just 5 minutes, okay? But you can start because today you will have more presentation than before than yesterday. You'll have two keynote address in this morning. So the first keynote address will be delivered by Professor J.R. Kayal about seismic hazard zonation, and the second technical sessions will be delivered by Dr. Saitluanga. Then after keynote address, we'll have a presentation from scholar up to 12:25 according to our program schedule. Then just after that presentation up to 7, then we'll have a lunch break. Then after lunch break, we'll have technical session 4. That will be our program. Then I would like to request Dr. Bobby Ansing to as a co-chair, because that our co-chair for this morning is Dr. Brotati Biswas. She is not here. That I request. Yeah, you can exchange with afternoon session. I request Dr. Bobby Ansing, is Geography Department faculty. Then after the keynote address is over, then the main chairman will be our Professor J.R. Kayal, an invited speaker. That will be today's program. Then now let's move to our respected chair, Dr. Saitluanga and Dr. Bobby.
Good morning, everyone. Once again, I welcome you on behalf of the chair. Today's topic is the one which was left for yesterday's last session. This topic is very important, and this is the future project which we need to take up very much in the state. I'm hoping that more participants will come. So I don't know, we still have 5 minutes left. I think, what is your suggestion, sir? Shall we wait for some more participants?
Okay. Whenever you say I'll start. I think
Fine, sir, we can
we start or?
Okay. Yeah. Okay, sir. Then, yes, you please proceed.
Sure, you're mic.
I'll go there, I suppose. So this has to go there. It's okay? Okay, good morning to you all. And chairperson and co-chairperson of the session, and Professor Kayal, and all dear students and dear colleagues. Now, this is, I think, last but most important topic that we could not do it yesterday, so I am just taking some time, more time. So sorry for that, but I will try to finish it within 15-20 minutes so that other times are not much disturbed. So we have seen that we understand the earthquake processes, we understand the source zones to some extent. We also understand what are the vulnerable zones for earthquakes. But we can't predict earthquakes as such with time, with specific time, space and magnitude. So in 70s, 80s, when the earthquake prediction research was in peak, since 2000, I think the whole world has switched over to microzonation study, because that is, I think, more realistic approach to develop a earthquake resilient society. Next one, please. Now, what is hazards? Let us try to understand the different technical terms. Earthquake hazards, that are the physical effects of seismic event, development of faults, fractures, fissures, etc., crustal deformation, liquefaction. All these things most of you are aware of it, in horizontal and vertical displacements. Then risk, as I mentioned yesterday, risk is hazards. These are the hazards, but risk is different. These hazards, if it is in the desert, in Rajasthan, Jaisalmer desert, there is no much risk. There can be fall, fractures, fissures, liquefaction, but that will not be a risky area for the human lives. So risk is seismic hazard into vulnerability. How many people are there? How the houses are, how houses are vulnerable for the total collapse. So all these things are taken into account to assess the risk. So hazard and risk are two different technical terms. Then the disasters and the type of disaster that we affect from the seismic hazards. The disaster comes in the form of casualties and damages to bridges and properties, houses and everything. And then comes the management, how you can handle the situation when the earthquake has occurred and the people are in danger. So these are the 3-4 terms that is clarified here. Next one, please. Then you might have all seen this map. There was a project in early 2000 to make this GSAP map. So whole Earth, the whole world has a map now. You can see that particularly in Indian continental part, you can see that how the Himalayan and Northeast India is seismically most risk or hazardous zone. So, and there are other parts like Chile and in the North America, this California fault and all these things. Next one. Now you are all aware of this seismic zoning map. So zoning map is there to give us a broad idea about the different risk zone. And according to this is earlier map. There were some 5 zones. This map was from 1993 to 1970. This map was prepared and then it was modified several times, and this was till the other day, this was the most known map. But since 2002, we have come out with another map. It's a much means further improved map after the Bhuj earthquake and Kilari earthquake and all. This map is further improved, and now the zone 1 is removed from this map. It is only zone 2, zone 3, zone 4 and zone 5. And just for layman understanding, we can take that the zone 5 means it is of the order of 0.4 G acceleration can be there, and that is a very high value of ground acceleration that can really destroy many things. So similarly, zone 4 is 0.3 G. I am talking about the G value, the ground acceleration, I think, which engineers are mostly concerned about that. So this is the broadly zonation map, but in spite of this zonation map, suppose in Guwahati, some earthquake occurs, or in Shillong or in Mizoram, as a whole this is zone 5, but within this zone 5 you will find that there are damage pattern is bit different. Some houses, good houses totally collapsed, and some poor built house is standing. So there comes the site effect. At what, on what soil, or on what foundation you have built the house. So here comes the site amplification. So as a whole, it is a very risk zone. It is coming in the zone 5, but within the zone there are several spots like your body. If I blow to your nose may break. But if I blow on your arm, you can withstand that. Similarly, Earth's crust is some parts, the Earth's crust is very strong to withstand the vibration, and some parts they may fail, and your house or engineering construction may collapse. So some spots are very sensitive. That is called site response or site amplification. So within this zonation map, we can further go for micro-zonation, particularly for urban development, for any engineering construction, dam or anything. We go for micro-zonation. Next one, please. Now, what are the micro-zonation approach? I think Mizoram University is one of the best universities in the country now to go for this, mapping. Because you have a very good earth science department, civil engineering department, and also you have got a geophysics department here where 2 young geophysicists have already joined. So I think this is a multidisciplinary approach for a micro-zonation mapping, and for that this university is very well equipped. There are, all experts are there, even including GIS. Thank you. Because the GIS is also a technique which is used for this micro-zonation. Now, what are the different approaches? The seismological approaches is, as I said, site response. We want to see which are the sites that gets amplified because of the seismic waves or that shock. And the site classification, that is based on VS30, means velocity of the shear. As I said yesterday, that it is the shear wave which is coming horizontal movement of the particle along the line of propagation. So that is actually most dangerous wave, and that velocity, if you can measure, so that will give an idea which are the site more vulnerable for damages. So VS30, and that technique is called MASOP. So this is another technique, and site response technique is also another technique that I will come to later on. Then we have to identify the hidden fault by micro-earthquake studies. So this is microseismicity. Yesterday I was asked, what does it mean, microseismicity and microseisms, all these things. It means, from your national network data, you may not be able to find out the actual, on the surface or in the hidden, whether there is any fault or not, because it's coming, say, magnitude 4.5 earthquake once in a year or so. But if you can go to the field and make a network with portable stations, you can immediately record thousands of events, particularly in a country like Northeast India. Because all the time small earthquakes are going on. That you can see in your observatory that every day you are getting some earthquakes. Some small magnitude 2 or 2.5 or 3 or less than 1, 2. So these smaller earthquakes are occurring as I said yesterday, that is, it goes in power law 10 times with 1 magnitude down. So you can make a micro-earthquake network for particular this city area. Suppose you want to do the micro-zonation. So you can make a network around this city, some 4 or 5 stations, and record the microseismicity for this particular city area only, not the whole state. For the whole state you need huge stations. And you can find out what is the microseismicity trend. That will give you the idea about the active fault on the ground or beneath the ground. So identification of the active fault. Geologically, a fault may be neotectonically active. It may not be seismically active. So to find out a fault which is seismically active need to be monitored by microseismic networks. Then comes geophysical methods, that bedrock foundation. When you are making a house here, construction here, what is the bedrock depth? You have got some loose soil, loose alluvium or whatever, weather layer, and what is the depth of that hard rock, that you should know. So to know that, you can go for electrical and seismic method that our geophysicists are here now. 2 young geophysicists have joined PUC here. So I think you have got expertise now to do this job. And I will briefly say how we can find out the bedrock. from these methods, from geophysical methods. Then active hidden fault investigation using gravity and magnetic also. By gravity measurements, very close station gravity measurement, you also can find out, as I said yesterday, the regional fault, Dauki fault and the Himalayan faults, how they are well reflected in the gravity map with high gradient of the contours. So similarly, that is for regional map, but for the very local fault, you can make a very close stations, say 100-meter spacing stations, and you can make a gravity map and find out the whether there is any fault is there beneath the ground. So all these things can be investigated by the geophysical methods. Then comes geological methods. That is that active faults by by geomorphological evidences and detailed. And you also need to know the detailed geological and lithological map. Means from the borehole data, drilling data, you can know your site area, what is the lithology in that. Also, drilling is also can be done to have a total picture of the lithology below your site. Then comes geotechnical method, that is N values. I think this is very familiar to the geologists and civil engineers. That is you can do some by drilling. They they drop the weight and they see how many drop is required to penetrate the surface, something like that. So that N number of drop. So that is the N values for the ground soil there. So N values can be measurement for assessing the liquefaction potential of that site area where you are going to make the engineering construction or whatever, or urban development, and landslide vulnerability. So these are the parameters that you need to assess to come out with a good microgeological map. Next one, please. You see, active fault or hidden fault, how they can dangerously affect our structure. This is the active fault map of GSI. These are the known, but there could be some active fault which are underneath, because the Killary earthquake occurred, there was no fault on the surface. The whole Killary, the whole Maharashtra is Deccan covered, the lava covered. So on the surface, no geological fault is mapped. And the earthquake occurred, 6.3 magnitude earthquake occurred. There was a hidden fault. So that we found out from the our microseismic study, aftershock studies, from the micro earthquake studies. We found that hidden fault which caused the earthquake. So this is of course a known map. Some known faults are there, but there could be hidden fault. This one, this Chichi earthquake damaged the whole dam, engineering construction, and they possibly did not study the geophysically whether this river itself is a fault. Had there been good gravity study or electrical method study, whatever, I think gravity study would have been much easier to do to find out whether this river is actually a surface expression of a hidden fault beneath the ground. That's what actually happened in Killary. There was a Tidna river and a tributary. At that junction, the earthquake occurred, and both these river, Tidna main river and the tributary, they are actually fault at depth. They are the surface expression of the hidden fault. So this river was a surface expression of a hidden fault, geomorphological expression of a hidden fault. And on the fault they did this engineering structure, and it totally collapsed. The dam totally collapsed. And you can see how on the active fault this is I think 2005 in Pakistani Kashmir building, and also in Turkey you have seen tall buildings just sank. And in Bhuj also on the active, this is quite a good structure, but it totally collapsed. So hidden faults has to be found out, particularly for microgeological map by microseismicity monitoring, and as well as by gravity measurements. Next one, please. Now, what is site response? I was talking about some sites are sensitive. Some parts of your body is more sensitive. Similarly, the earth, some spots are more sensitive for failure. Now, what are those sites? Just schematically you can see that, suppose your earthquake occurs here, and the earthquake waves hit this surface here, which is hard rock, bedrock, and there is some sediments here, some say 1 kilometer thick or whatever. That sediments, when the seismic rays pass through this sediment, through this soil, it gets amplified. And the same structure, this structure standing, this structure is affected. So this is the site, means the site within 100 meter or so has got different responses to the same construction. So this is site amplification or site response that you have to study for microzonation. Now how you can see a practical example. This is schematic, but this is practical example you can see. This is on some Loma Prieta earthquake aftershock. When the monitoring aftershock, they make a closed network. Some 4 or 5 stations they made, and those stations are in different geological formations. Some are in the hard rock, some are in the Holocene mud, some are in the quaternary, alluvium. You can see for different stations that same earthquake, and in that closed area, within say 50 kilometers or so, or maybe less than that, has caused seismic waves. In the hard rock is much less amplification, and in the Holocene mud soil, much higher amplification. This is P wave and this is S wave. So S wave is much amplified. So this is why you need to do the site response study for microzonation map, and this is the practical example. So we can do this site response study by 2 methods. These things, I think, a project is under proposal where we are trying to do the microzonation map of Aizawl city, and I think these are the 2 methods by which we can do this site response study. One is very popular method, it works very well, that is H by V method. But just by putting, you don't have to wait for the earthquakes to come and do the site response study. You just put your station on the ground for few hours, 2 hours. 2 hours is fair, good enough. And you record the ambient noise, just the noise you record. Again, shift that station to another 100 meter, another station to 100 meter distance. Record another 2 hours. By one station you can make, I think, 2-3 measurements, 2-3 stations measurements in a day. Even one station, it may take some long time. Even one instrument is fair enough. But if you have 2 instruments, naturally you can cover more stations, because you have to cover at least some 1,000 stations for the whole Aizawl city. So you measure the ambient noise. Just put the instruments for few hours, for 2 hours maximum, and record the noise. And there is a built-in software, or there is a technique which you call Nakamura technique. You can take the ratio of the noise amplification. You can take the ratio of the H by V. H means horizontal component and vertical component. Your instrument has got 3 components. 3 component instruments are now available in the digital system. So you are recording 1 vertical component of the amplification and 2 horizontal component of the amplification. Horizontal means east-west direction and north-south direction, horizontally, and vertical component of the noise amplification, of the noise record, say, noise record. So H by V means you take both the average of these 2 horizontal records, and by V means vertical records, the amplitude of the vertical record. So amplitude of the horizontal record is working or not working?
We need to change the battery.
So amplitude of the H by V means of the horizontal, average horizontal, both the horizontal you can do averaging. Average amplitude of the horizontal component and the vertical component, that ratio is site amplification factor. So very simple, physics is very simple, and that is also built in software, so no problem. The software is available, and there are qualified people here, geophysicists here, so they have done, I think, without much help, they have already done the fault line solutions of the digital records, so they are in the job. So you record the noise, ambient noise, just ambient noise on the ground. No, don't have to do anything, any special arrangement for the stations. Just put on the ground and record the noise, do the H by V study and get the amplification factor, and also you get another parameter at what frequency that site is getting amplified. These are the two very important parameters you get. And or by, more scientifically, by spectral ratio. Suppose this is a record, and at one hard rock station you have got record. So you take the ratio of that at the hard rock formation and this your mud formation or quaternary formation. So that ratio also can give you the site amplification factor. But I think for doing quickly, you don't have to wait for the earthquakes for the second method. The first method is very quick and it works very well. Next one. Now our first effort from GSI was the Jabalpur earthquake. Because we have seen in Jabalpur, it's a very interesting earthquake. I didn't go for the Indian earthquakes source zones, but I am quickly telling you, there is a Narmada reed basin here, this is the Narmada south fault, this fault. And the earthquake occurred to the south of the south fault. And the Narmada north fault is here. And between these two faults, the reed basin is going some 1,000 kilometers long, Narmada reed basin. So the main shock occurred, the star is there somewhere. Yes, this is the main shock occurred to the south of the south Narmada fault, and these are the aftershocks. And this is, I think now you understand, this is the main shock solution by the global solution, this is by the IMD solution. There, this is component is bit less, but this has got, this is reverse faulting or thrust faulting with some strike slip component. And this is we have done for the aftershocks. For all the aftershocks, we made a composite solution that is also, say thrust faulting or reverse faulting with strike slip component. So these are the fault plane solutions, and this is the fault on the surface. This was mapped, and this is the aftershocks, and this is the main shock. So, and this is, you can see the interesting point. Normally the main shock and aftershocks are within the maximum intensity zone. The maximum intensity was of the order of 8 or 9, 8 I suppose. And the after earthquakes are away from the main damage area. So that is interesting part also. Anyway, I am not going to details through this. Now, within this maximum intensity zone, we found some buildings, well-built buildings totally collapsed. And just within 50 feet or 100 feet, another building, maybe equally built or maybe poor than the damaged building, that is standing. So there we could see visually that what is the site effect for the in the same intensity zone. So you have made a contour map. This is the highest intensity zone, but within that there are some spots which are more susceptible for damage and some spots which are less susceptible for damage. So that is site response. So we took this, next one please. I didn't go for the source zone and all. So we made a collaborative project with Italian experts, and from India we were from GSI, NGRI and IMD. And we, as I said, we were taking just recording the noise, ambient noise. And just some examples are shown here, different types of examples are shown here. You can see some 100 samples, because you can take some 20-30 second sample and 2 hours you are recording. So you can take several samples and you can take average of that. So this is several samples are taken, and you can see that at some sites there is a amplification in this frequency. This is frequency versus amplification. That is H by V ratio. At what frequency that site is getting amplified, means seismic wave is getting highly amplified. So that amplification, say, factor and the frequency, that's a number, because H by V, naturally it is a number. There is no unit. So it is a ratio of the amplitude. So it's a number, say 4, amplification factor 4 or 5. It does not mean anything, but it is higher than the other sites. So amplification factor, and what frequency that amplification factor is high, that you are also getting from your sample data, at what frequency it is. So that frequency and amplification factor are plotted, and you can see there is amplification, there is de-amplification, there is de-amplification, there is amplification. So various frequency, at various frequency and various sites, the amplifications factors are estimated. And there are, since time is a bit short, so there are various types of rocks at what frequency they are getting amplified, they are all classified. So different sites are classified for different types of soil and how they are behaving with the say seismic waves. So that is one example of how the sites get amplification, at what frequency they are getting amplification. Both these factors are important. Next one. Now we also make a map of this site amplification factor, how the whole area, what are the sites are more vulnerable for damage, and at what frequency map, that we call it predominant frequency, the frequency at which the site gets amplified. And some sites get amplified, say at a frequency 5 to 7 Hertz. Some sites maybe at a 3 to 5. So like that, at different frequency range, the sites gets amplified. And to the engineers, this frequency parameter is, they are not bothered with the amplification factor, they are more bothered with the frequency. Because that frequency at which the site gets amplified is important for their design. Whether they will go for multi-story building or two-story building or one-story building. So if the building frequency is same as the site amplification frequency, then the building will collapse. It will resonate. So civil engineers mostly concerned with the, again I think it's gone, concerned with the frequency, at what frequency the site is getting amplified. Can you hear me? I think I am louder enough. So that is I think a little bit clear to you how we estimate the site amplification factor and the predominant frequency at different sites in the study area. Having done that, now you can do the bedrock studies. And for the bedrock studies, we have different methods. Here I think we have demonstrated some. This is again in Jabalpur. I think this is by what data? This is, I remember some velocity. This is, I think this is electrical. Hello, working? Hope, yeah. So, by electrical sounding, our young geophysicists are here. So, by electrical sounding means you are, sending in some current through two electrodes and measuring by two electrodes. There are some different configuration. So, by measuring that, you can find out the resistivity factor of the, of these underground soil or underground formations. So that you can map. Nowadays everything is in software oriented analysis. So you can see that this is hard rock, or say the basement rock or bedrock is much shallower, something like at this depth range, maybe 4 to 5 feet or 4 to 5 meter, and these are the much deeper. The bedrock is much deeper. So these sites are much strong than these sites. So electrical methods can give you the configuration of your bedrock, means at what depth the bedrock is there, means hard rock is there. So that is one good information for microzoation parameter. Then your velocity, as I told you that you can measure the VS velocity. That also you are getting it here, where the velocity is low and this patches, you are getting that parameter also. Maybe it is other way around, the rate is high. So you can see that this is higher bedrock at shallower depth, and also the VS is also higher here. Then you can take a section of the velocity section, and you can see your bedrock is more or less like this. This is your thick, weather layer or whatever, and your bedrock is here. This is higher velocity. So this is the bedrock configuration. So engineering construction, engineers will take care, this information for their design of the engineering structure. So you can study the bedrock depth by electrical method, by VS method, and that information also taken into account for the microgeneration map. Next one. Now this is the ultimate product. All these information are brought to GIS platform, and then you come out with a map which is hazard map based on the geology, geophysical information, and the site amplification and predominant frequency. All these parameters are taken into account and brought to GIS platform, and they have come out with a seismic hazard map. This is seismic hazard microgeneration map. That means this part of the Jabalpur city is more vulnerable for damage compared to this green earth part and all. So this is what is a seismic hazard map, and this is seismic risk map. I have explained what is risk and what is hazard. So this is the seismic risk map of this was our first attempt from GSI after the Jabalpur earthquake. Then we made another attempt in Guwahati city. I'll also show that. That was in more detail. Next one. Yes. I will take another 2-3 minutes to complete it. Now, as I said, if you can read it, I think possibly this is geology of the Guwahati city area, and this is the basement topography made from the electrical and seismic methods. This is the, if you can read, I can't read from here. Landslide data. This is site classification from the meso and from the amplification. This is, I think, amplification. The predominant frequency map. The site, this is PGA map also, another parameter, peak ground acceleration. That is also, measured here, means from the strong motion instruments. So you can directly get the acceleration value. So that map is also there. Predominant frequency is also there. Site amplitude. So all these maps, all these informations, which are, you see, it was very lengthy process. Maybe it took us some 2 years to do it, and this maps then brought onto a GIS platform, and that was the seismic hazard map is now ready for the Guwahati city area. This is Brahmaputra river, and all the red patches are vulnerable for damages. So any such map is so important for making any engineering construction in this city area or further development. Is very much useful, and from this map we have again, next one please, we have again did the land use survey, means how much of these lands are used, means because as I said, if you are in a desert area there is no risk. So in the Guwahati city area we have found how much land is used and how the populations are there. All these information are taken into account, and then from the hazard map you have come out with a seismic risk map. So it is so important map for the disaster management authority also, that immediately if there is an earthquake in the foothills of Himalaya near Guwahati, the disaster management authority can take decision without any news from the TV or whatever. They can immediately rush to these areas where the most vulnerable area for damages. So this is not only helpful for the further development of the city or retrofitting of the old buildings, and earthquake design for the new buildings, not only for that, but also for the disaster management people to take care of the most vulnerable zones for immediate support or immediate help. So this is the utility of microgeneration map, and I think this is high time, particularly Aizawl city is on the hill slope. So your landslide and slope instability, all these parameters should be studied carefully. And site response study, as I said, is very easy method, very quick method. And I think these are the very important parameters that you can study and come out with the microgeneration map, at least for the further development of the city and for retrofitting of the old houses or old buildings. Next one, please. Now you see how the lesson is taken by Japan. This is my own picture. I have taken this picture myself. I had been to Kyoto and Kobe. So this is Kobe earthquake, 1995 Kobe earthquake. And you can see, I think geologists will be surprised. I was also so thrilled. You see, like a textbook type of thrust faulting, if you can see the picture from behind. And that thrust faulting on the surface, and that they have preserved like a museum for the next generation to see it. And the whole destruction was recorded, and some are stimulated. It was horrifying. It was, we experienced that when the earthquake came, how the sound and how the building were collapsing, those things are recorded. Some are actual records, some are stimulated. So these things are in a museum, they have kept for the next generation to know. And even this one is, and there is another picture by side of it. A house was totally destroyed. So that picture I could not fit here. So that one and this one are kept at the site where the earthquake occurred. These are kept for the next generation to see. They take the lessons and they, dissipate the knowledge to the next generation. And after this earthquake, this is 1995 earthquake, and they found that the buildings which were built before 1980s all totally damaged, destroyed, and people had a lot of losses. So they made it a mandate. Every building should be, they made it a mandate, already made it a mandate, and the buildings which were built after 1980s, they are not destroyed, but the buildings which were built before 1980s, they are all totally destroyed. So they made it a mandate that these buildings, new buildings, this is the ERI, Earthquake Research Institute, where I was a visiting professor there for a couple of months. This is the old building, ERI, University of Tokyo, Earthquake Research Institute. The old building is now retrofitted, you can see. They are retrofitted by the cross bars. And just in front of that, there is a road just here within the campus. New building is made, and this is seismically designed. There is a bush below this whole building, and it can take the shock like you travel in your car. The shock absorber, it takes the shock, and the building only swings. It does not collapse or no cracks or nothing happens. So as I said in my keynote address in the first day, I was enjoying the earthquakes. So that is the experience. So Japan has made an earthquake resilient society, no casualties by earthquake. And the lesson we take in Bhuj, on the fault zone, again they have built a new Bhuj city. After the 2000 earthquake, the Bhuj was destroyed by 7.7 earthquake, and the new city has come up, but they have not considered our map. So this is again vulnerable for another large earthquake if it happens after 100 years or 200 years. So we don't take lesson. Next one. Now I will just take another 2-3 minutes. How this is, I think I need not to go through it. This is how the disaster management people, they take care, and as I mentioned, now they can take care of this map to send their help, and how they should, these are all known to them. Maybe you can read my slides, so I don't want to slide, only time is short. So these are the steps the management authority they take. Next one. And this is tsunami. I was telling yesterday that how the Sumatra earthquake, the tsunami, we are in a much rather safe position in India. That is why we had no experience of tsunami for last 500 years, and this was the first tsunami that we experienced from Sumatra. It propagated to, but we are in a safe position means it takes about 3 hours, 3 hours plus time to reach to Indian eastern coast of India. So enough time for warning, whereas Japan has hardly 20 minutes to 30 minutes time for the warning. So now we have made a warning system for the tsunami. Means we have got some stations in the seafloor and on the eastern coast, and those data are immediately analyzed whether the earthquake is on the seafloor, whether by thrust faulting, and they accordingly they can make the warning. So tsunami warning is practicable, and it was not being done in India before, but now it is being done, and it is working very well. So tsunami warning system is possible, and since we are India, we are much away from the tsunami-genic sources. We have enough time for evacuation or for but within 200 meter or 300 meter, there should not be any large engineering construction that may be damaged by the tsunami. So anyway, tsunami warning system is working now in India, and you can see, I must mention that though my time is so short, you see this earthquake occurred, this map you see, this is the earthquake, this red star over here, and this is if you can see this color, this is the ruptured zone. Means something like 1300 kilometer ruptured zone, long fault. The rupture propagated up to Andaman, North Andaman Island, and this is Baratanga, I suppose. There one tree, they are all my pictures, our pictures. One tree, you see such a long distance. The one tree was split, and it was separated by some 1 meter. You can see the tree is splitted and it is separated, the two parts. So this was the energy of that 9 mega earthquake. So that was, and the Car Nicobar Island, the air base was totally washed out. And the chief engineer of that area said, I never heard about tsunami. So tsunami was unknown to us. And a English girl, school girl, when they were on a holiday in Thailand, she told her parents that tsunami is coming. We must go away from this sea coast in the beach, Thailand, Phuket beach. The father gave importance to that girl, and he called all the tourists that let us go away. My daughter is saying that tsunami is going to come. She knew that tsunami is going to come because she was told in the class that when the sea behaves abnormally, receded something like 1 or 2 kilometers out, it recedes the waves, then the tsunami is coming. So that she was told in the school, and she saved some hundreds of lives in the Phuket sea beach. And in India, in eastern coast, the villagers, when they found this abnormal behavior of the sea, they called more villagers to come and see how the sea is behaving, and they are all killed. So ignorance kills us, not the earthquake. Yesterday some professor told that. So that was the ignorance of tsunami. We had no experience of tsunami. So this is it is possible, and this is the center. Next one. An earthquake warning system is, I suppose it is now installed. India is trying to install the earthquake warning system, and Uttarakhand initiated this effort. I don't know whether it's already in working condition, but this is of no use for common people. This is useful for the very fast, say bullet train or some power plant, and they can automatically switch off. Automatically there will be switch off when there is a large earthquake, because there is hardly say 30-40 seconds time. So during that time, the power plant and other things can be automatically switched off. So that warning system can only be useful for that purpose, but this warning system will not save our lives, because as I said, if you are in the ground floor, you may go out, but if you are in the multi-story building, you have no time. It is risky to go out. Next one. I think I will not take any more time. So thank you all. We have to live with the nature. So earthquake do not kill the people. It is the buildings kill people. That was my conclusion. Thank you so much. I went very fast because very tight program. I am feeling guilty that I could not finish yesterday. So if you have got some quick query, you can ask me, or you can ask me in the, yes, please.
So many questions, very interesting. That is the micro level generation. I came late after 50% the presentation is over due to some meeting. But now everybody is thinking we are different specializations. I am geology, you are geophysics, and another one is geography, another one is civil engineering. how to involve them? That is my basic question.
Yes, all are involved. Yes, yes, you missed it. Because geology will give, microgeology needs some, some all parameters. Geology, geophysics, engineering parameters, geotechnical parameters, all parameters.
To remove their doubts, that's why I am asking.
Yeah.
And in MSc level, we have PG program level. Disaster management, one paper common for all. Whatever MSc, MA, MCOM or management, the UGC has mandatory to give that paper, disaster management. In that we have the dissertation programs also there.
Right.
That way, microgeology level donation, each and everybody take up.
Yes.
Now urbanization is everywhere. in
Yes,
India.
it's high time,
People
yeah.
from that way, micro level donation at district level.
Yes.
District headquarters are packed up with the migrated
Yes,
people.
yes.
Those who are survival, etc.
Yes, I think it's high time now for
this way
microgeology.
we can
Yes.
collaborate.
Yes,
That's
sure, sure. I am always there, available. I am very near to you people also.
it is good.
So, but I suppose your university is very well equipped for such study. It is high time now to start. It is late but never, better than never, never. So it is late, but we can start right now. And I think there is a proposal already from geology department, from your university. And you need, to start with just one portable seismometer for site amplification study, and other study you can do. Geology and geotechnical study, other study you can do without much expensive instruments. And geophysical, I don't know how they are equipped. Some geophysical study also they can carry for the bedrock. So I think these slides will be there, and you can study yourself, and you can always call me to clarify. And this is one of the, I think this is the topic which we need today to understand for making a earthquake resilient society. Thank you so much. Thank you.
Thank you. Sir, one more last.
Yeah, please.
Because these earthquakes we don't predict, sure, 100%.
Yeah.
But when it is stress levels, we expect where stress is built up,
Yeah.
where the subduction zones or fault zones,
Yes.
whatever it is
Yeah.
there. Release of the stress, when it will be released, maybe we can expect based on your geophysical, whatever, geological weak zones. That way we can predict how much power.
Okay, good question. But I should not hurry. It's a good. It's a good question. I must reply to it. It's for all of us to know. I think I skipped that slide, or I will take another 1 or 2 minutes. One is called, I think this is your domain. One is called paleoseismological studies. As I said, instrumental record is hardly 100 years, 120 years. So from the instrumental data, no much statistical study can be done for earthquake prediction. And geophysical because, as I said, it's difficult to know when and where. There is a paleoseismological study which is done by geologists mostly. You can go to the old earthquake site, say 1897 Shillong earthquake site. The study has been done, and from the seismite, you understand seismite, due to the liquefaction, the mud was totally liquefied, the soil was liquefied, and then over 100 up to 200 years, the deposits have been deposited. So that mud is solidified. It's called seismite. So that they, by trenching, they find out that liquefied or seismite, you should say. They find out the seismite and they age it, and they find that 3 such seismite they have found, and they found that in Shillong, the average recurrence time of such great earthquake is about 500 years. And along the Kopili fault, the similar study was done, and it is found that, as I said, 1869 there was 7.4, 1943 there was something 7.2. So it's a gap of something like 75 or so years. So they also found 100 years recurrence time at the Kopili fault zone. So these are the 2 earthquake source zones for large earthquakes in Northeast India, and the recurrence time is this. And as you say, the stress, when the stress, to some extent they are doing it by the GPS study, but again the exact time they cannot say, but they can say which fault is more stressed. Yesterday I shown one slide that Sagaing fault is more stressed than the CMF. So which are the fault are more stressed, that can be measured by GPS study. But exact time when it will rupture is yet to be, find out. Thank you so much.
Thank
Yeah.
Thank you, sir.
Thank you. Thank you very much.
Thank you for delivering such a beautiful presentation, interesting and informative presentation for 2 days continuously without any this one interruption. And if any this kind of questions from the student side also, please, I hope for last 2 days sir has been giving lectures for 2 days. I hope a very good nice questions may come from student side also, please. Yes.
Yes.
Sir, I have a question because based on your last session yesterday, you mentioned that because earthquake prediction is not likely to happen, forecast maybe. So it means that now, of course, I think now all these building codes have happened so to make the earthquake, more earthquake resilient these structures. But what about in the event of an earthquake like in news around here, with the existing structure, how can we be more?
I think you missed my lecture.
Yes, I did.
This today's lecture was for that only. I have answered all the doubts today morning. This is one of the, I think, most important lecture today morning I had delivered here. That is, I gave a examples also. The old buildings, when you make a microgeneration map, that I have described how to do it. When you make a microgeneration map, and when you find your old buildings, big multi-story building or whatever, or two-story or one-story building, is on a very vulnerable zone for damage. From that microgeneration map, you can find out that your building is in a very highly vulnerable zone. That building needs to be retrofitted. And new buildings on the red spot, means on vulnerable spot, must be designed accordingly, earthquake resilient design. So old buildings should be retrofitted. I have shown the examples. Maybe that time you are entering. The old buildings in Tokyo University, they have retrofitted, and new buildings they have made, earthquake resistant design they have made. Even you'll be surprised in New Zealand. I was shown by my friend one multi-story building. It was on a highly vulnerable zone. They lifted the whole multi-story building and put the design, put the bush. Lifted the whole multi-story building, some 5-6 floor building, and put the bush and then put the building on that. So this is what to be done for the old buildings which are on the red spot.
But we don't have technology like that.
That I don't know how they did it. I don't know.
That's already been experimented in Punjab. I think last year it was done. One of the building was shifted on those rollers.
Yes.
And something was done again on that
Yeah.
foundation.
It is done. Even in India we have done it. Yes.
China, otherwise they have been doing it for
Yes.
something.
So retrofitting of the building is must for the old building, or particularly for the multi-story building. It's a must. You are in a hilly slope. So I think one more parameter need to be studied here for microgeneration. Geologists, my friends are here. I think the slope instability. That is another factor should be taken into consideration for microgeneration map. So I think with all this, I really enjoyed, and I wish I can interact with you afterwards, maybe in the dinner time or maybe in the lunch time, whatever. And I think I will not take much time.
Thank you, sir.
I'm already encroached the time. Thank you.
Well, before we proceed to the next session, clinical session, may I invite Professor Vicky Sati to give a certificate to our invited speaker, Professor J.R. Kayal.
I could receive the certificate. Yes. Okay, nice to receive. This is some certificate. Thank you so much. Thank you. Thank you. My great pleasure. Yes, sir. Even when I teach, I get energy. When I don't teach, I don't feel energy.
And
When I teach, that's spontaneous. This is my inherent. I am son of a teacher.
So you can continue.
also to Dr. Saitoma, the chairperson of this session. And Dr. Bobby. Well, now we invite Dr. Saitoma for his keynote address.
So, Yeah. You will share this session again, sir.
Okay.
You work.
My goodness. Okay.
Yes, sir.
Other sides.
Hello, hello. Good morning, everyone. It is a great honor for me to speak alongside the world's most renowned geologist, seismologist, Professor Kayal. In the meantime, it gives me lots of nervousness. I hope I can deliver what I've prepared. Yesterday, we listened to his wonderful talk, and he has covered most of the topic regarding the seminar. And yesterday, our secretary, he branded me as a geologist, as a seismologist. But I don't consider myself as a seismologist because I just happened to take up the subject because at that time there is no one to take up the topic. So because what I'm saying is I am from a pure geology background with no mathematics and physics. So to dig deep into the subject, there is lots of limitations. But these days we have lots of researchers and students who have that maths and physics background, and I hope that in the future we may not need to consult other agencies, or we can work here with our own knowledge. I think that will happen very soon. And so I am putting this as my topic, status of seismicity and its forecasting in Mizoram. This map is prepared by, or this is the work of Malik and others. Here we see that there is one fault which Sar has mentioned yesterday repeatedly, Cabo fault, and we have Chorachan-Purma fault, which is drawn till the southern tip of Manipur, and we have this north-south trending Saigang fault. All these major faults in the Indo-Burmese ranges, they are all north-south trending transform faults. And even though in their studies they do not mention any earthquake that happens inside Mizoram, if you see this clearly, this is the place where we have that 2020 earthquake. This was published way before that, but there are some few events within Mizoram according to their studies. So we have prepared this map. This is almost 40 years of data which we collected during our research. During that time, we have seismic stations in Agartala, Aizawl. It was running during that time. Then one in Manipur, IMD Shillong, one in Itanagar. So what we used to do is we used to exchange this data. We prepare phase data bulletin. There we pick up all the earthquake that happens within a day, and we prepare a bulletin. So we exchange that bulletin, and from that we plot this epicentral map. So I think this must be fairly accurate. This is Aizawl, and this is the mud fault. Sir have mentioned and this in his talk yesterday also. And Sheet-held fault is there, which is now concealed beneath the Bengal alluvium. And most of the big magnitude earthquake, they happen inside the between this Kabo fault and Sagaing fault. And of course, we have lots of earthquake in this Shillong Plateau. This is the depth section or the depth distribution of earthquake till 2009, because that station which we had in our college, it was functioning till this time. So most of this data were also data which we generate from our stations. And this is a map or the prepared by this Arun Kumar et al. Data which they collected from NACE, NGR, IMD, and Manipur University. This is the CMM fault or Chorachampur Mouth fault, which I've mentioned earlier, because most of the failed earthquake, from my experience, which we felt in Mizoram, especially in Aizawl also, they are mostly coming from either this Sagaing fault or Chorachampur Mouth fault. That means these two faults must be very active, as Saris already mentioned. This is Aizawl, and I will not go into detail regarding these beach balls because it has already been mentioned yesterday. And we filtered out all the earthquakes except for this Silhead fault and Mud fault during these 40 years of studies, and we have found that there are lots of events falling in these regions. And you know, this Mud fault is very, very prominent. If you look into your Google Earth, you will easily find or trace the fault line. There is Aizawl, and that 2020 earthquake of this, some call it Vapai earthquake and some call it Tran earthquake, whatever the name is. It is somewhere here. We will go into detail regarding that later. This is a part of Mud fault seen from Lungdar village, East Lungdar village. That June 2020 earthquake, it happens on the Monday morning of 22nd, and I think we all know the magnitude. This NCS has put the magnitude as 5.5. So 2 days after that earthquake, we went to the epicentral area, and this is the MSK scale, which we use for taking the observations. Sir has mentioned yesterday that this is the most refined scale, so we use this scale. And this is the epicenter locations plotted by different agencies. And when we do the MAGE assessment, we found that it is not related to this mud fault, which I have shown earlier. Instead, this CMF fault must be related with this earthquake. I've shown you in the first slide that CMF fault is drawn up to this border, and till now there is no studies on the southern side. But it looks like this earthquake is very much related to this CMF fault. And this fault plane solution shows that it is a strike-slip fault. The highest intensity scale that we gave was 8 here in the epicentral area. We have covered more than 30 villages, and very interesting thing is that Zaukotar village, which was situated around 20-kilometer aerial distance, they are the most severely affected area. These are the photographs that we have taken. This is the newly built church at Zaukotar, and you see this. It is all twisted from the foundation. They have to dismantle this this church later on. This is the police station, and this is the barrack, and this is the inside of this police station. I don't know whether this this police station is still there or not, but from what we have observed, they also need to dismantle and build a new one. Sir has mentioned about the soil amplification. If you see this isoseismal map that we prepared, we cannot enter this site because this is the Burmese site, and it is during the height of COVID. We are not allowed to enter this area, so we just made this isoseismal plot from Mizoram side. This town, Zaukotar town, it was situated on the riverbank of Tuikui, so that must be built on the very resilient alluvium deposits. That's why the destruction is most in this town. And these are the maps which are made GPS measurements made by this Taylor and Yin, Galaut, and all. From these GPS measurements, it shows that at the syntaxis zone, while the mass of the Indian plate is moving in the north-south direction, it was bending, and it moves down. The plate is moving down, and it because this is confirmed by the orientation of the fault in the central Myanmar basin. All these faults which we have seen here, they are almost east-west, northeast-southwest direction. And this is the work of Gang Zheng, 25 years of GPS measurement. If you look into this closely, it looks like Mizoram. We are in the middle or the center of a twill or center of a vortex, I don't know. That may explain why mud fault is northwest sounding, southeast trending. This is the work of Malik, which I have shown in the first slide. This also confirmed these studies. This is the fault and lineament maps prepared by Mirsak, Mizoram. These are the confirmed faults. So you can see from this map, we have lots of faults and lineaments within the state also, but we don't know whether all those faults and lineaments or faults are active. So, is it possible to predict an earthquake? Let's see. The most famous one is this prediction by Frank Hogerbritz, who say that there will be 7.5 magnitude earthquake. So 3 days after his prediction, there was an earthquake in Turkey-Syria border. But this Dutch researcher is very clever. I mean, he doesn't precisely tell the time and the date. He just said sooner or later. So this kind of prediction, is very general. There will always be an earthquake that fits this kind of prediction. Suppose if I say that there will be 5.5 magnitude at Vapai 100 years from now, that will fit into this kind of prediction. So he was rather lucky that his prediction is just 3 days prior to the big earthquake. So there can be 2 types of prediction or forecasting. One, I put it long-term prediction, and the other one is short-term prediction. In long-term prediction, what is the probability of having an earthquake within a specified time interval? And short-term prediction, will an earthquake occur in the next 24 hours? So animal prediction, sir have mentioned this yesterday elaborately, but I have one experience myself. Before this 2020 earthquake in the morning, just I think 15 or 20 minutes before the earthquake, we have a German Shepherd dog. He came up to our room, he scratched the door, and he barked softly for a few minutes. After that, he went to my daughter's room and he did the same thing. And immediately after that, this earthquake happened. So that means my whole family were awake when this earthquake happened. I was skeptical about this prediction earlier, but I have experienced it myself. So we don't know whether what signal that they have detected, whether these are electrical charges or magnetic field, change in magnetic field, we don't know. But they have sensed something. Whether that will be accurate every time, I don't know. So that means I have a good prediction device in my home. So if you want, to be alerted, you just give me a number. I can call you anytime, whenever my dogs scratch my room. This is a cartoon in a Chinese seismological textbook. They also mention about this animal behavior, unusual animal behavior. And radon gas emission, this is very common, and some professors and teachers here in the university also take up this project. They have studied the radon anomaly in mud fault. Radon, usually they say that 9 days before the earthquake, there will be about 10 times increase in radon emission, and that emission will start concentrating till 2 days prior to the earthquake. That is how they used to detect radon for earthquake prediction. And change in electromagnetic field, this may be the signal that animals detected, but that is not yet confirmed. And there is a company called Quick Finder in US. They try to use this electromagnetic field, change in electromagnetic field near the fault for earthquake prediction. You can find out, or you can check out their website. Change in helium concentration before this Loma Prieta earthquake in 1989. This is also radon emission before the 1995 Kobe earthquake, and SAR has elaborately mentioned about the prediction regarding resistivity, water pressure, well levels, geyser activity, and change in seismicity yesterday. So I'll just put this through these few prediction which scientists have carried out. This is the, so let's move on to the long-term prediction. We have seen this map several times, and this is the ring of fire where 80% of the world's earthquakes are concentrated, and here in the Mediterranean Himalayan belt, about 15% of earthquake happens every year. And for the long-term prediction, we can employ these paleoseismic studies. We can identify the fault trace. I have mentioned earlier that this mud fault is very prominent. We can imply or employ these paleoseismic methods. We can dig out the trend somewhere in this fault. We can find out the signatures from the hidden sedimentary layers. This is the picture which I have taken when we visit the eastern part of Mizoram. We don't know whether these kind of structures generate earthquake or not, but if they fall along the active fault line, they may be worth studying. And fault segmentation is also a good method that was employed by many agencies and many scientists in different countries. This is the work of Vong Vivan in Vietnam. Fault lines, they are rarely a straight line. We have seen the mud fault. That is, of course, we can trace it nicely in the Google Earth, but in reality, they are not a straight line. So they are obstructed by topographic changes in lithology. So we can divide all this line into different segments, and we can concentrate on one segment, and we can study whether that segment has generated earthquake frequently. We can employ that paleoseismic studies like active fault mapping. We can dig the trend somewhere. We can find out the signature of fault hidden below. They have done the same thing in San Andreas fault as well. Fault segmentation. This is mud fault, and I have shown you in the previous slide that this fault must be active, because this earthquake it was triggered. I think I cannot see the date. Is it in this year or last year? Can you see the date, please?
It's 2023. April.
2023. I think this is this year, if I'm not mistaken. This year. Yes, April. There was a 3.5 magnitude earthquake. So it looks like this earthquake is at this portion along the mud fault. So this shows that we cannot ignore the activity which is happening along this line. And of course, this one is 17 January for 4.5 magnitude earthquake. This may be associated with the Georgian-Pumbao fault. And we can predict earthquake using this loading and breaking method, because earthquake usually happens when the load exceeds the strength of the rock. This is the loading maximum. When it reaches the maximum load, it will break. Just like when we bend a stick, we apply the stress, and the strain will be accumulated at the center of the stick, and eventually it will break. Something like that. So they have employed this method in Park Field. There was a series of earthquakes at regular intervals, 1958, 1981. So when they take the mean of this earthquake, they find out that earthquake happens every 22 years interval. So they expect or predict earthquake to happen during 1987 to 1993. They were so confident that their confidence level was 95%. But the earthquake did not happen until 2004. That means the earthquake is 16 years late. But they were, of course, they were right about the size, they were right about the location. But just that they were wrong about the time, because they were very precise with the time, but even 16 years late. So predicting earthquake at a very short interval may be, they're usually wrong. For long-term prediction, as I has mentioned earlier, GPS studies is very important, especially for the Northeast also. Right now, if I'm not mistaken, we don't have any active GPS stations in Mizoram to study the deformation. And we can employ this method also, like a historical seismicity pattern. Because in Assam also, yesterday Sarah has mentioned that there is a seismic gap in Assam, where likewise this is the work which they have carried out in Bay Area, large Bay Area in California. And they found out that earthquakes, they have been concentrated in some years, and there will be a gap, and there will be another earthquake. Using this method, they predict that there will be a 70% chance that the earthquake of magnitude 6.7 will happen during 2000 and 2030. We can employ the same method for Mizoram and the adjoining areas also, because as I've mentioned, there are lots of data, historical data, which we can use for this kind of study. So why might short-term or intermediate term forecasting be possible? We can know that the earthquake or big one is coming from these 4 shocks. But in that 2020 earthquake, yesterday I called up one of my friends over there. I asked him whether they have experienced any foreshock before the main event. He said that there was a big jolt on the Sunday afternoon around 4:20 p.m. He told me. And they did not have any unusual animal behavior. They did not detect or feel any foreshock apart from that one, it seems. So in earthquake, early warning, every second counts. So I'll give this example. Suppose there is an earthquake and the city is located around 50 kilometers away from the epicenter or away from the focus. And we heard that, or we listened earlier, that the shear wave travel around 2 to 5 kilometers per second. And to reach this city 50 kilometers away, we can divide this with the 2 kilometer shear wave, and we have 25 seconds minus 10 seconds to detect the strong motion. That means we have around 15 seconds to warn those people living in this city. But suppose if we say that the effect extends up to 100 kilometer, 15, 15, that means 30, we'll have 30 seconds warning time. So that earthquake of 2020, according to the forecasting method that we talked earlier, there may be another earthquake generated from this area in the future. And we have heard that the magnitude can go up to 7. So Aizawl is situated at about 100 kilometers away from this epicenter. So that means we have around 30 seconds before the arrival of the shear wave. And Champhai is located around 50 kilometer aerial distance. That means Champhai will have 15 seconds to prepare for the upcoming earthquake. So what can we do during this time? Everything has to be fully automated. Yesterday, Sir has mentioned that there is one multi-parametric station in Jorhat, no, sir? That one. I have seen that with my own eyes. They put up a big screen. That was a very huge project. They have set up seismic stations all over the northeast. In Mizoram also, I think they have put at least 3 stations. So they can monitor those earthquakes in real time. So whenever there is an earthquake anywhere in northeast, it will pop up on the screen. So for this kind of warning, we need fully automated system kind of thing. This is the technique that they have used in US. They call it Shake Alert. There's a phone app for this. So if you are if you happen to be located in that region, California region, to be precise, if there is an earthquake, this sensor will detect the P wave. You know, P wave is the P wave traveled fastest, so it will travel, or it will reach the station before the S wave, and there is a sensor. This sensor will send a signal to the earthquake alert center, and immediately people will be alerted through their phone app. In Japan, they call it Yurekuru call. First time I heard, some might have heard this kind of warning system. So in the future, we may also have this kind of warning systems, which if we put up, a good number of stations on the within the state, if we collect all those data in the processing center, and without the use of or help of man, the computer will generate the earthquake. It will analyze the earthquake, and it will, within a few seconds, it will send out the signal. Like that one, we can get the alert for an upcoming earthquake. So what can we do in 60 seconds? We can shut down delicate and dangerous equipment. Doctors can stop surgery, move away from high-rise building, steep slopes, especially in Mizoram. We can make public announcement. This may be too late within 30 seconds. Or we can dive for shelter. Japan has a very elaborate network system. So with all these systems, they can accurately give the warning. On the contrary, we have only 3 stations in Mizoram. These are the recent earthquakes that we recorded from our stations. Mike will later on elaborate on this earthquake. So this is the same prediction from this the same guy who predicted Turkey earthquake. It was circulated in the social media earlier. So we are due for a very large earthquake, just like the one that happens in Turkey, according to his prediction. And this is also circulated in the WhatsApp and other social media. This person who circulated this, he is very precise. He said that during February 10th and 18th, there will be an earthquake similar to Turkey. So this kind of message, people used to make up, they just created or they just created this kind of message and circulated in the social media, and people, they are very panicked when they see this kind of message. So instead of concentrating or spending our time much on the assessment or the prediction or the forecasting, I think the best way is to concentrate, pay more attention and importance to long-term forecast, like retrofitting, obeying building codes, obeying by the law, better legislation, insurance, emergency plans, education to the public, and preparedness. I think that is the end of my slide. Thank you.
Thanks to our second day keynote speaker, Dr. Saitlamala, HOD, Geology UC, for giving a wonderful speech on various fault lines on our Northeast region. And a different earthquake occurred in between 1999 to 2009. With the magnitude, and the speech also highlight two important fault lines which led to occur earthquake in our Aizawl city, which and the destruction happened in the past also. That is Mount fault line and the Chuchapur fault line. Sir, thank you for your insightful speech on this keynote speech. Thank you, sir.
So one question.
Okay.
Can you go back to your map?
Which one?
Yes. Yeah, that one.
Okay.
See, the CMF lies at the Manipur side here. So in 2014, Lahalat, scientists who discovered that CMF published a paper regarding the 9 years GPS recording, and in this paper he wrote that the CMF is not active. But in 2020 earthquake, I was listening on this talk, and he said that the CMF is the one that caused the Mizoram earthquake. So in 2015 again, that Sarhalat along with Professor Tiwari, they published a paper on the mud fault, that it is not active. So will there be a chance that can cause an earthquake like the CMF?
That earthquake studies that I have shown you, the isoseismal lines and all, we have published in the current science with Dr. Galaut. And in that also we have written that it is the activity of this Churachampur mud fault. And during my studies of this mud fault, we believe that it is not active, but recently, as I have shown in the picture, there are some earthquakes. Just before yesterday also, I think Michael saw in his slide, there is another earthquake that is along this line. That means it may be triggered, I don't know, because of this plate deformation.
Okay, thank you. Now we begin our technical session. We are already running at the time, given time slot. So let's start our technical session. First, presenters, the first technical presenter, please submit your this one. Your this one PPT to sir.
Sorry to
Those who are
interrupt.
going to present in the first this one session.
May I request the two people on the first bench to give
Yes.
a certificate to our invited speaker and to our chairperson. Ms. Pintai, please. A certificate to Dr. Saitonga. Certificate to our chairperson, Dr. J.R. Kayal. Yeah, another one.
All the first thing, these presenters, you will get only 8 minutes for your presentations, okay? And there will be 2 minutes for discussion. That's all. Please maintain the time while presenting your presentation. 8 minutes for presentation, 2 minutes for discussion on the presentation.
Hello? Kalian. Hey, Carson.
Okay, good morning, everyone. Today my topic is focal mechanism and fault plane solution of earthquakes within Mizoram and Indo-Burma regions. And my name is Osang Generalte, and currently I'm doing my PhD under the supervision of Dr. Saitonga. And today I'm very happy to present in front of our eminent scientists, Professor J.R. Kayal, and all my friends, research scholars and teachers among here. So, and we have listened many things about the predictions, forecasting, and many things about the earthquakes. So today I want to present one of the source mechanism, because in order to predict, in order to do predictions, in order to forecast, we need something which are originating. So today I'm trying to explain about the mechanism of earthquakes. You know, earthquakes is it is let's begin with the simple definitions. It is a sudden shaking of the ground due to the energy which are produced by the wave from the earth's interior, and then we are able to record this. There are different faults, and we are able to record the waves which are coming from the subsurface, from the interior of the earth. And then we know that earthquakes are generated along the faults. We have different types of fault. We have normal fault, we have strike slip, and we have reverse fault. And in reverse fault, if the dip is less than 45 degrees, then we call it as a thrust fault. And in order sometimes all these faults we cannot see from the surface. They are hidden in the subsurface. So how could we notice, or how could we find out that earthquake is produced by this type of fault? And depending upon the types of fault, then we are able to tell whether the earthquake can be large, whether the earthquake can be small, or something like that. So for that we need to know very detailed things about the what is the mechanism which originate in earthquake. So the wave which are coming from the fault, or the, we can say the hypocenter, then we are getting the, the waveform which are recorded in the station. This is the earthquake, the seismogram which are recorded in the college, Pachung University College. So this one, as sir have said, that there are three components. This one is the vertical component, this one is the north-south component, this one is the east-west component. And sir also have said that for the side response, we need to consider the vertical and horizontal component of the seismogram. Anyway, that is the other topic. So we currently have three seismic stations at Aizol, South Khobung and Lunglei. And we have recorded many earthquake events which are along the Surachandpur Mao fault, even the Sagaing fault, and even the Kabo fault. And also there are some events which are around here. And till now, so far, we do not, if I'm not mistaken, there are, we don't have any events within Mizoram. Maybe seeing more data, we might also have it, the local events. So this is the initial process that we have the seismogram, and then we need to do the processing, data analyzing, everything. We need to have a good signal to noise ratio, so that depends upon the location of the station. So we will have to select the stations where the signal to noise ratio is much better. So as I have said in the beginning, that the study of earthquake has a societal impact. So in order to assess what is how to reduce or how to minimize the effect of an earthquake, we need to understand what is the dynamic process, what is the physical mechanism, what is the physical structures, and that will tell us about the seismotectonics of the regions. And for that purpose, focal mechanism and fault plane solutions is one of the methods by which we can determine how the source mechanism or the structures of the associated fault of a particular earthquake is behaving. So in this study, I'm using the waveform inversion techniques for the determination of earthquake mechanisms. So the result of the waveform inversion will give us the nature of the associated fault of a particular earthquake events. Suppose, for example, if an earthquake of magnitude 6.1 occurs in the Indo-Burma regions, so we collect the data, we do the waveform inversion techniques, and we are able to find out the moment tensor solutions, and then we do the beach ball representations, and from there we are able to tell that, oh yes, it is a CMF fault, and then it is showing this kind of strike slip motions, and also we can tell that if the earthquake is epicenter is exactly at near the CMF fault or mud fault or even the Sagaing fault, then we can tell and correlate with the past research papers, and then if that correlates well, then we can able to tell and study much more details. And for these stations, more stations is very important. So here currently we are running 3 stations here within Mizoram, and it means that we can record more accurate, or we can say more stations, or this kind of detailed study will be able us to help us to in studying the source mechanism. And this is the the beach ball representations and the types of its associated fault. This is, as we can see here, this is a truss fault, which means that the dip of the fault plane is less than 45 degrees. And then the truss fault, in truss fault, we are having this kind of beach ball representation. And here we have to consider about the principal stresses like sigma 1, sigma 2, and sigma 3. And depending upon the orientations of those principal stress, we are having different kinds of fault. And here we are having truss fault. These are the 3 major different faults. And here we have truss fault, and here we have normal fault, where the sigma 1 is the greatest, and these are the how it is represented in the beach ball. And here is the strike slip fault. These are how it represents. And besides this, what I want to tell is that these are only the three general beach ball representations of these faults. But in reality, there are, the CMA fault, they are very, they are very long, and the mud fault even they are very long, and then the sagging fault. And whenever there is a slip or the motions along the fault, we do not have the pure strike slip fault, or there might be it might be associated with some slip which are accompanied with, suppose for example, strike slip fault, or the reverse fault might be accompanied with small component of the strike slip fault. So that's why we are having different representations. So based on that, but we have to base this, but our informations which we have done during the inversions, it might show not a pure strike slip or strike slip fault like this, but it can also be associated with some other truss fault or something like that. So they can, for our easy understanding, it means that they can be mixed. But we can tell that we can say like strike reverse fault with a small strike slip component or something like that.
Sorry to interrupt, you have only 1 minute remaining, please.
Okay, sir.
Just try to maintain time.
Okay, this is the steps for the waveform inversion. So we need to use the velocity model, then the raw data preparations, and then the ultimate aim is to select the frequency and the depth trials, so that the synthetic and the observed seismogram is we are having the best fit, so that will give the best result. This is the method which we have followed, and here this is the inversion result. Here we have the DC percentage of 97.6, and we have the different parameters for the fold, and we can have plot the beach ball. And this is some of the works which I have done. So we can see that the earthquake of 20 events was using the global CMT catalog for the mechanism study within Mizoram and Indo-Burma regions, and there are different epicenters. Some of them are within Mizoram. These are the epicenter which on the 5.5 magnitude 2020 earthquakes. So here it shows the strike slip fault, and here there are two conclusions by different authors. Malsom et al., they conclude that it was related to the CMF fault, and Bubul et al., they conclude that it is related to the mud fault. So they consider that mud fault is active, but there are two conclusions by two different authors here. Anyway, so here here we can see that both their conclusions are conformed with the strike slip natures of both the mud fault and the Churachandpur Mau fault, and these are the data and the result used for the study. And this is the 6.2 magnitude earthquake which occurs in 2021 11:25. This was recorded by our stations. So this shows that the epicenter was along the Churachandpur Mau fault. And this is the, okay, let's skip this one. This is the same methodology. This is the observed and the synthetic seismogram for the combined three stations, which give the result of DC percentage of 97.6, which give the strike dip and rake of the associated fault. And this is the result which we have got from the three stations. Here the epicenter was near the Cabo Valley, and then here we are having a reverse fault which has a low dip that we consider it is a truss fault, and there are many studies about the Cabo fault. Many authors have different publications regarding the Cabo fault because it is having different natures. Some of them are saying it is a strike slip, some of them saying it is a dipping truss fault by Key et al. In 2022, and some of the said that this is a dextral movement strike slip fault by Yang et al. 2020 along the Cabo fault. And the present study from the three stations, we consider that the Cabo fault is a reverse fault with a low dip amount or truss slip, and it might also be associated with a small component of the strike slip fault. Okay, this is the one earthquake which we have found along the CMF fault. This is the epicenter, and this was waveform inversion is done from the 3 stations which are recorded within Mizoram. And here we see the strike slip fault, which are represented by the beach ball. And from the global CMT catalog also there we can correlate that the beach ball which are prepared by using the GCMT catalog also. So this is the one which we have studied, and this is the epicenter here. They are very close to each other near the CMF fault over here, and then they are showing the same kind of beach ball which is the strike slip fault. And currently we are recording the stations. We are having 3 stations at Aizol Salkhobung, and we are also collaborating with Tripura, Agartala stations this year. So by this year, all the events we are going to have the 4 events for whatever earthquakes recorded. So we hope that that will give us a better result in futures. Oh, thank you.
Can you quickly go to the slide where you are inferring the Kabul fault is the
Okay, sir.
is the quality fault for that after that you have made the study. Yes, this one. No, not this. Not other here. No.
This is the related to this one, I think, sir. This one.
You are correlating this one with Kobe fault. Is it? This after this Faultman solution.
Yes, yes.
And you are saying it is a thrust fault.
Yes.
Then which nodal plane you infer for thrust for the positive fault? South dipping or east dipping or west dipping?
It's is dipping, sir.
That means if it is east dipping, then it is not thrust, it will give us dipping. Your low angle nodal plane is
This one.
Is west dipping. Is that right? And I am just a bit confused about the literature. Kobe fault
Yes.
is dipping to the west or dipping to the east. So,
So-
I wanted to understand from your point.
Okay, okay, sir.
So we can discuss later on. Okay.
Okay, sir.
We will discuss it later on.
Yes, yes.
I think this is one of the good information. I think your records are very good, and you should show your, among all the solutions, you should show your solutions with different colors, say red,
Okay.
and GM solution some color, and your 2-3 solutions you show in different color, in your red color or whatever.
Yes, sir.
Then we can understand what it is. Thank you very much. Very nice presentation.
Thank you, sir.
Any questions from the floor? Okay, thank you. So before you start the presentation, again you please try to message you back.
Okay,
You
sir.
have had in the presentation 2 minutes to discussion.
Okay, sir.
Good afternoon, everyone. Good afternoon, my respected teachers and dear seniors. My name is Prof and I am BTech student, Department of Civil Engineering. Today I am going to present my seminar topic is Importance and Need of Earthquake Resistant Structure, Design of the Seismic Resistance Building. First is, all we know what is an earthquake. In our life, all we had experience in the once in a lifetime in the earthquake. So I will give a small definition about earthquake. The earthquake is mainly the natural disaster of the phenomenon of occurring with all the uncertainties. Mainly earthquake is the shaking of the earth surface and the resulting of the sudden release of energy of the earth surface, and that earth surface of the lithosphere is mainly creates the sudden waves is called the seismic waves. There are mainly two types of seismic waves. First one is body waves and second one is surface waves. Body waves is also have two types. Number one is P waves and the second one is S waves. P waves is mainly called the primary waves. It is very quick travels through the earth. Surface is mainly P waves travels through the solid surface as well as the fluid surface. As you can see the pictures of first P wave. P wave force is mainly move like backward and forward direction, and it will get the soil become compressed and expanded. Second one is the S wave. S wave is also called the secondary wave. Secondary waves mainly is the slow travels is compared to the P waves. It mainly travels through only the soil material, soil surface, solid surface. And S wave is mainly waves move the perpendicular to the movement of the wave. Mainly the effects of the earthquake is first one is ground motion, second is landslides, third is tsunamis, fourth is aftershocks, last one is liquefaction. Liquefaction means during the earthquake our bearing capacity of soil will be very disturbed. That's why the soil behave like liquid. Because of this because of the earthquake, soil behaves like the liquid, so there is soil mainly behaves maybe different settlement will occur of the soil. Third slide is based on the magnitude of earthquake. Earthquake, the magnitude 8 and the higher than 8 is indicates the great earthquake, and major earthquake range is between the 7 to 7.9. Strong earthquake is in range between 6 to 6.9. Moderate earthquake is range between 5 to 5.9. Light earthquake is range between 4 to 4.9. Minor earthquake is mainly 3 to 3.9 range between, and the micro earthquake is less than 3. This is a classification of the seismic zones in India. There are mainly the 5 zones, seismic zones in our country. Accordingly zone 2, zone 3, zone 4 and zone 5. Zone 5 is most dangerous zone in our India, which covered entire our northeast part, and some part of the also zone 5 is cover some part of the Jammu and Kashmir and some part of the Ladakh also. Zone 4 is covered the North Bihar and Uttar Pradesh also. Zone 3 is covered Kerala, Orissa, Rajasthan, Gujarat also. Zone 2 is covered remaining part of our country. IS code for earthquake resistant design. Before we construct a earthquake resistant building, we can go for some guidelines which is given to Bureau of Indian Standard. This IS code is very useful during the construction of earthquake resistant design. First IS code is 1893-2002, which is used for designing the earthquake resistant design for structures. Second is IS code 1426-1993. This code is used for practice for earthquake resistant design and construction of buildings. Third one is IS code 13827-1993. This code is used for improving the earthquake resistance of the earthen building. In Aizawl, I don't see the earthen buildings, but I came from Assam, and in my state there is lots of earthen buildings is there. So during construction of earthen building, this code is used as a guidelines. Fourth one is IS code 13928-1993. This code is used for improving the earthquake resistance of low strength masonry buildings. Last one is IS code 13920-1993. This code is used for practice for ductile detailing of reinforcement concrete structure of the subjected to seismic force. Ductile means what type of steel we have to use. This code is given. Next is what are the factors affecting of the settlement of the building during the earthquake. First one is structural height and the load of the building. Structural height and load of the building means if the one structure,
Excuse me, you have only 1 minute remaining, please.
if its height is more and then the load is also more, then the load is coming to the soil is very heavy, to soil settlement may be occur. Lateral strength of the building. Lateral strength of the building is means to we know the earthquake mainly shaking like horizontal way, so we have to increase our lateral strength of the building. We can go for increase the lateral strength used like a shear wall, bracing, etc. Third one is adequate stiffness of the structure. This is means our structure should have stiff. Stiff means what? Our structure should be strong enough. Fourth one is ductility and flexibility of the building. Our building should have the proper flexibility of building. If we don't use if our building is not flexible, then building will easily collapse during the earthquake. Types of soil on the which the building is constructed. Types of soil is very important before constructing the any building. We can go for the soil test. Architectural and the structural design. Our structure should be the structure like rectangular and square shape. Use of less affecting mortar and porous bricks. Next is what is the principal earthquake of the resistant design. First one is the building shall withstand almost no damage to moderate the earthquake. Second one is the building should no harm the livelihood under any situation. Next is how seismic waves affects on our structures. First is inertia forces on the structures. See the first picture. When the during earthquake, when ground shakes, then the building resting on it also moves according only through it. So according to the Newton's first law of motion, when ground will move, building will accordingly move, but the upper part of the building has tendency to stay in its original position. But because of the wall and columns are connected to the roof, so they are dragged to accordingly follow them.
Please come to the conclusion part. Your time is already over.
Conclusion is earthquake resistant construction is important in earthquake prone area. The building can resist earthquake forces with almost no damage. The building shall not collapse or harm human lives during the severe of earthquake motions. There is a lack of awareness in the earthquake disaster mitigations, avoiding non-engineered structures with unskilled labor. State-wise awareness programs have to be conducted by fully exploiting the advancement in the information technology. Urgent steps are required to be taken to make the caudal provisions regarding earthquake resistance construction undebatable. Thank you.
She's just a BTech student. She attempted very good on this national level seminar. But next time when you present, try to focus on your team in there. Do not go unnecessarily. You will waste all time on that, and other speakers also. Do not waste your time in the less important part. Try to concentrate what you have done, what you are finding apart. Be elaborate, expand on that matters. Okay? Thank you.
Yes, sir. Thank you.
Again, you please maintain your time. Okay?
Okay,
8
sir.
minutes presentation, that's all. 2 minutes for discussion.
Okay. Good afternoon to everyone. My name is Hirokjyoti Soria. I am doing BTech in Civil Engineering from School of Engineering and Technology, and I am doing a project which is related to seismic design. So today I am discuss about the seismic design analysis of G+6 multi-story building, multi-story residential building, focus on northeast region of India. As we know that earthquake is random in nature and it is unpredictable. So we have to do for design a structure, we have to do static analysis and dynamic analysis for a structure, or it is because we are belongs from northeast zone, so northeast India. So we have for a civil engineer, the first thing we have to see that the seismic load. So India has divided into as per earthquake zoning plan, India has divided into 4 categories: zone 1, zone 2, zone 3, zone 2, zone 3, zone 4 and zone 5. And zone 5 has high seismicity and zone 2 has lesser seismicity. Since northeast region comes under zone 5, so construct a structure in northeast zone, we may face many challenges. So it is depend on load carrying capacity of the building, stiffness, ductility, damping, and mass. So how to calculate the seismic analysis? To know the data, we have to follow IS 1893 2002 part 1. So what is 1893 2002 part 1? 1893 2002 part 2002 has divided into 5 parts, but first part is related to building. IS 1893 is an India standard code for seismic design of a building. So we can get the all data for a design of a building from this code. When we construct a structure or building, so there are mainly two types of force acting in a building. One is gravity force and another is seismic force. Gravity force is nothing but the force of the load of self weight or life load of the building, and seismic force is like it is due to earthquake. So we can see from the picture that gravity load acting downward vertically and seismic load acting horizontally to the building. So we have to calculate both of them for design a building. Seismic analysis. So seismic analysis is a part of structural analysis. We can calculate the seismic force by using seismic analysis. So why it is important? So seismic analysis, from seismic analysis we can imagine a building during earthquake, how to behave the structure for future. It can carry the earthquake load or not. So we have to do seismic analysis for a structure. There are mainly two types of seismic analysis. First one is static analysis and the second one is dynamic analysis. Before going to static analysis and dynamic analysis, we have to know what is static load and dynamic load. So static load is the load which is not changing according to the time, like self weight of the building, like dead load. Dead load means if we for example, if we imagine a bridge, the structural weight of the bridge is dead load and moving vehicle is the moving vehicle from the bridge is the load of vehicle is said to be life load or dynamic load. So dynamic load is those load which is changed according to the time, like for example earthquake load, wind load, etc. So static load and dynamic load is subdivided into two parts. So according to the building structure, height of the building, we can analyze the method. So for design a seismic structure, we need some data, that soil type, what is the loading resisting system, what is the structure of the frame, importance factor, seismic zone, etc. So we are constructing a building in Guwahati. So the soil type of Guwahati is medium. So and we are doing in frame special RC moment resisting frame. So we can get R value from the IS 1893 2002, and zone factor we can collect from because northeast comes under zone 5, so we can collect the Z value from IS 1893. So there are several types of building. For each building the importance factor value is different. So we are constructing residential building, so the importance factor of residential building is 1. So permissible increases in stress. As per IS 1893, when earthquake force are considered seismic design of a building, it is 3 times greater than the normal building. If we imagine a normal building and seismic resistant building, the weight of the normal building is 1/3 of seismic design building. So if we put here load 3 kN, then lateral load of seismic lateral force is into 3 into 3 into 9. So we have to do the seismic analysis, because seismic design and normal design. So normal design, if normal design is taken by only live load and dead load. In seismic design, we can carry live load, dead load, and seismic load also. Depending upon the problem, there are 2 types of method: seismic coefficient method and response spectrum method. So for calculation of seismic, the first step is we have to calculate the horizontal coefficient. How the how the design of horizontal seismic coefficient, which is horizontally how far the building move. So we can calculate the AH from this formula, which is given by IS 1893 2002.
Please come to your finding
Okay,
and
sir.
conclusion part. The time is about 1 minute,
So-
7 minutes.
So after that, we have to calculate natural fundamental period. So what is natural fundamental period? When the earthquake occur, buildings wants to move to original structure to another structure. So it is the time taken another structure, another position to original position. How many time taken? So it is known as natural time period. We can calculate the median soil SA by G from IS code. We can get the value of SA by G from IS code. So I am giving an example how horizontal seismic coefficient can be determined. So it is, we have calculated 0.009. Seismic base shear. So base shear is how when the earthquake occur, the earthquake force acting in a building laterally, horizontally. So we have to do the base, how the building base can carry the load of lateral force. So we have to calculate the seismic base shear from this equation, which is given by IS 1894. And later we have to calculate QI. QI means the how many lateral force is coming. So floor by floor, if we construct a multi-storied building, so if we calculate the QI value, we can get the lateral force of. So I'm just giving an example. So base shear, load, seismic load, and height of the building from the base. After that, we have calculated QI. So QI is you can see this from this picture load diagram. From the ground floor to top floor. Top floor, the lateral load of top floor is higher than the first floor.
Please stop. Yeah.
Okay.
Conclusion. Yes, very good.
So we from this presentation we can understand how to design seismic with a different kind of method. So in previous days, this method is calculated manually by writing in a copy, but in nowadays we have advanced software like State Pro. So using this State Pro, we can easily calculate easily design a seismic building, and it is very less time consuming. So in Northeast, many people not go for seismic design because it is due to costly compared to normal building. But the bottom of the line remains that seismic design is essential for a building, especially for northeast region. Thank you.
Yes, next speaker, please come. All right, please try to maintain time. 8 minutes, 2 minutes discussion, total time 10 minutes.
Good afternoon, everyone. My name is Talom Sara. And today I will be presenting slope stability analysis along State Highway from Champai to Zaukotar village, Mizoram, India. And I will try to finish my presentation within time. In here areas, slope modification is a critical problem and which affect the human as well as the environment. And the stability of the slope mainly depends on its geologic structures and geotechnical properties. And these geologic structures and geotechnical properties characterize the slope forming materials and also characterize the stability of the slope. And this is one drone image of one location within my study area. As you can see here, there is a rock fall and sliding of soil due to a rock cut, this slope modification plan. So it has great effect on the stability of the slope. This is the location of my study area. From Champai to Zaukotar, it runs around 20 kilometers. And this is the coordinates, geographical coordinates, and mainly geologically, the study area comprises of barrel formations, which is of Oligocene age. This is a geologic age. And we have a field study, and we have carried out field works where we collect the attitude of the rocks, like joints, dip and strike, and deep directions. And we carry DGPS locations, and we have also collected soil samples. And this is a Brunton compass. This is just for a scale. And for rock mass rating, we have carried out 6 basic parameters. First one is UCS, uniaxial compressive strength, where we take where we are using Rocksmith hammer for UCS, and that Rocksmith hammer value we again analyze using Click and Tayman formula. And for rock quality designations, we are considering only 1 square meter area, and within that 1 square meter area, we are taking a volumetric joint count. And for the condition of discontinuities, we observed visually whether there is infillings between the discontinuities, and we also measure the distance between the discontinuities. And here, spacing of discontinuities is mainly referred to the length between the discontinuities. And the orientation of discontinuities is the strike and deep directions of the discontinuities. And groundwater we observe visually. And for the kinematic analysis, we are using DIPS 7.0 software, and this is a stereographic projections. And we are analyzing 3 types of failure. This one is a planar failure. As the name suggests, there is a failure in the rock slopes, and the instability upper portion part sliding above the stable portions of the lower. And this is the, this is the diagram. This upper portion is the unstable part, and the lower portion is the stable part. And this unstable part slided in a planar way. And this is a wedge failure. For wedge failures, discontinuities intersect. It means 2 or more discontinuities intersect, and we have a wedge-shaped failure. And for this one is a toppling failure. For a toppling failure, there is a differential weathering in the upper portion. Here the rock portions, and there is a rotation in the lower and the upper portions. And due to that rotations, there is a differential weathering, and the rock usually fall. And this is a stereographic projections. I will explain in the result and discussion part. And for a slope mass rating, we are using Romana. And for slope mass rating is mainly to analyze the stability of the slope, and we are considering 3 adjustment factor F1, F2, and F3. And this one, F2 and F3 are mainly the discontinuities, the properties of the discontinuities. And this is the formula. SMR means slope mass rating, and RMR is the rock mass rating basic, the value, and F1, F2. We are multiplying all the F1, F2, and F3, and F4 is the excavations, mode of excavations. And this is the table for adjustment factor. This one is for F1. This is for planar, toppling, and wedge, and this is for F2, planar, wedge, and planar. And this is for F3, and this is for the mode of excavations, the method of excavations. I will not go much into detail. Coming to the result and discussion part, as you can see here, there is a bedding, and there are so many discontinuities like joints. And all these joints data we have collected, and we are measuring using this Banton compass. And this is the bedding you can see here. This is the Google Earth photos, and this red portion is the DGPS locations, the rover part. This is the DGPS base, and we are carrying the rover, and we are taking manually all these. The red portions are the DGPS part. This one is the base of the DGPS. And for a rock mass rating, if I said earlier, uniaxial compressive strength, this is a rocksmith hammer. So we are striking the outcrop of a rock. And that UCS value we are recording, and in the laboratory we are analyzing using Killick and Tayman formula. And we are using N by NR type. So this is the rock mass rating after Benesky, 1979. The UCS value is 62.04 for location 1. And we are rating 7. And this is the RQD value where we done the volumetric joint count. And this is the spacing of discontinuities. And this is the discontinuity length, separation of aperture, all this. And this is the groundwater. When we carry out the field work, the groundwater condition is completely dry, so we put dry. And from that data, the RMR value is only 37. All this for location 1, location 2, location 3, up to location 8. And we are classifying from that RMR value class 4. And location 7 is class 7. Only location 7 falls in a fair rock. The rest of the locations are poor. And this is the average stand-up time. It will last only around 10 hours for 2.5 meter span. And this is the cohesion value from the RMR table, and this is the friction angle. This is the kinematic analysis. We are using deep software. I think most of you don't understand this. This picture represents, see, we have a globe like this. We have Earth, imagine we have Earth like this, then the upper portion is northern hemisphere, lower portion is southern hemisphere. If we cut into 2 halves and remove the upper portion, there will be a flat top and the lower will be bulging. So if we put the lower portion towards the wall side, and the flat surface area will look like this. This is the flat surface area. I think you can follow me. And this is the north. North is the 0 degree. And east is 90 degrees, south is 180. This one is west is 270 degree. And from that, we are analyzing our data. This is the strike of the slope. The slope angle is around 76. Since it is a cut slope, the slope angle is very high. And this is the slope orientation. Deep directions, the deep directions of the slope. It is around 179, 169, something like that. So this green portion is joint 1. This continuity is 1, and this is the joint 2, and this is the joint 3. And this red portion is the vulnerable area from our observations. So location 1 shows there is a chance for direct toppling and 33% chance for direct toppling. So these are the, I will not go much into detail. This is for site 1, site 2. This is for site 3 is wedge. See, these are the discontinuities, and there is an intersection for wedge failure. So this is the vulnerable area. And for site number 6 also, there is a possible chance for wedge failure, site number 7 and 8 also. And from that kinematic analysis and rock mass rating, we are calculating a slope mass rating, rock mass rating, and these are the adjustment factors, and this is the method of excavations. After doing the observations and analysis, these are the slope mass rating value. And this is for joint 1, joint 2, joint 3. This is for joint 1, joint 2, joint 3 for each site, and the rock falls into class 3 up to site number 3, and from site number 4 it is very bad. See. And for the rock mass description we classified as a normal, and for the stability it is partially stable. And for the very bad rock mass description, that is class number 5, it is completely unstable in the area. This for location 5, 6, 7 and 8. Coming to the conclusions. From the analysis, 50% of the selected location shows a very low RMR value, which range from 28 to 39, and the average stand-up time is only 10 hours for 2.5 meters span of time, and the uniaxial compressive strength is between 4 to 4.16 to 70.84. And from the kinematic analysis, location 1, 2, 4, and 5 could experience toppling failure. Toppling means that differential erosion 1. And for the location 7, 3, 6, 7, and 8, we could have a chance of wedge failure. And the SMR value falls for 1, 2, 3, and 5 is, 1, 2, 3 is class 3, and their SMR value is 51, 53, and 48 respectively. And this is for location 5, 8. These are my references. Thank you.
Okay, thank you.
Good afternoon, everyone. My name is Ramwati, a research scholar in Center for Disaster Management under the supervision of Dr. Ladin Puya. The topic that I am presenting today is climate-induced disaster in Aizawl district with special reference to Tlong River, Sairang, Mizoram. According to National Disaster Management Plan 2019, climate-induced disaster can be classified as meteorological, which includes cyclone, extreme temperature, lightning, heavy rain, etc., and hydrological like flood and landslide, and climatology like drought, extreme hot and cold conditions, forests and wildfires, etc. This is the impact of climate-induced disaster in Mizoram during 2007 to 2019. Landslide have claimed 254 lives, and the total number of life lost was 254, and the total number of injured was 553, and 10,934 houses were fully damaged, and the estimated loss in terms of money was 125.92 crore. The the main factors that causes or that accentuate this climate-induced disaster is mainly the pattern of rainfall and temperature. So here is the temperature of Aizawl during 2007 to 2022. The maximum annual average was recorded in 2009, and which eventually decreases and continues to climb from 2016. And in the monthly temperature distribution, the month from April to October had crossed 22 degrees Celsius. This is the seasonal temperature of Aizawl during 2007 to 2021. And this seasonal temperature has shown an enormous fluctuation in every season. And for the winter season, we have considered November to January, and March and April in spring, and May and June for summer, and May to August for, in summer, and September and October in autumn. This is the annual total rainfall in Aizawl. The minimum rainfall with 1,547.7 millimeter was recorded in 2008, and the highest in 2017. Even a single extreme rainfall can cause a flood in the river system. This is the change detection map of Long River Sairang during 2008 to 2020. The total area occupied by water body and forests have decreases, while the total area occupied by vegetation and settlement has drastically increases. This is the monthly rainfall distribution of Aizawl during 2007 to 2022, and where the highest rainfall were recorded during August and followed by June. And due to the heavy rainfall in 13 June 2017, Sairang Tong River was flooded, and the massive flood has affected over 700 farmers and 500 sand miners, where the estimated loss for the farmers range between 35,000 to 250,000, and the sand miners' loss per day was 1,250 to 1,800 per day. And to conclude my presentation, and so that we can be cautious also, and we have estimated the rainfall return period using Weibel's formula, and the return period of 124.62 millimeter rainfall is 5 years, and 154.43 is 10 years, and 171.87 is 15 years, and 184.24, that the same amount that we received in 2017 is expected to be the return period of 20 years. And we have also calculated 95% dependable rainfall, which is 57.52, and which has a return period of 1.05. And the probability of maximum rainfall equal or exceeding to 120 millimeter, which the same amount has caused flood in Sairang Tong River, has a return period of 5.23. That is all that I want to share with you. Thank you.
Next speaker, please.
Respected chairs, Professor Kayal, Dr. Saitlonga, Dr. Bototi, teachers, and my dear friends, A very good afternoon to you all. My name is Lalming Sangi and I'm a research scholar in the Department of Geology under the supervision of Dr. V. Vanthang Liana and Dr. Din Puyang. Today I will give a presentation on the topic characteristic of soil and rocks with seasonal change and their effects on slope stability. Okay. Firstly, as we all know that Mizoram is a sedimentary terrain where most of the area, the bedrock is covered by sediments with a thickness which varied from place to place. And also we can say that more than 50% of the area in Mizoram, especially in Aizawl, falls under the slope or slope angle of more than 20 degree. We can say that slope may be one of the triggering factors in the stability of the slope. Besides the slope, we can also say that the behavior of the soil when they are in contact with water, when they are under the conditions of wet and dry, they can be also results in the slope failure. So according to Collins et al. 2004, when the weather soil is in highly steep terrain is exposed under hot and dry conditions for a very prolonged period of time, and if it experiences a heavy rainfall, then slope stability is highly reduced due to the decrease in the strength of the soil and also the rock. These are the mechanical properties of the soil which I study for this one. Like the natural moisture content, for the soil I study the natural moisture content, the Atterbach limit, like the liquid limit, plastic limit. Liquid limit is the minimum moisture content through which the materials behave as a liquid, and plastic limit is the minimum moisture content through which the semi-solid becomes plastic. And liquidity index, plasticity index, and consistency index, I got it from natural moisture content and liquid limit and plastic limit value. And I perform direct shear test where I find the value of cohesion value and angle of internal friction, which will be important for finding out the factor of safety using the slope stability analysis. And I did unit dry test, and in rocks I did the slag durability test. This is my study area. My study area is in Zhuangtui, which is one of the locality in Aizawl, fall under Ward number 1 of Aizawl Municipal Corporation. And the selected area Zhuangtui is suffered ground movement since 1987. And here we see that, sorry. And here this is the recent photograph which is taken last year in the month of September. This failure again occurs during the monsoon season. These are my methodologies: sampling, laboratory works, and analysis. First of all, soil sampling. I collect the samples from 2 locations. The first samples was collected on the month of April 2021, which is a dry season. And after that area suffers a wet-dry cycle, then on 2022 October, I collected the samples again from the same location. And here I did the laboratory work. This is the natural moisture content test, liquid limit test, plastic limit test. And from this value, using this formula, I found out the plasticity index, liquidity index, and consistency index. And about the direct shear value, from this I did a compaction test, and from that optimum moisture content, I proceed the direct shear test, where I got the value of frictional angle and cohesion. Now the result of soil test. Here the dark brown color, it represents the samples collected during the dry season, and blue, it represents the sample collected during the wet season. And this is for location 1 and this is for location 2. And here we can see that liquid limit decreases from 40.7 to 38.31. Same thing for plasticity in plastic index, plastic limit. And plasticity index also decreased by some small decimal point. And liquidity index, it increases. That means the tendency to become liquid increases. And consistency index increases, and the moisture content also increases. The same similar difference occurs for location 2 also. And this is the shear strength parameters for location 1 and location 2. And here the dry density increases. That means the moisture content increase. Angle of internal friction, it decrease. And cohesion value, it decreases. The same thing happens for location 2 also. And from using the parameters of angle of internal friction, cohesion value, and dry density, I performed the slope stability analysis using limit equilibrium method. And here the first figure, it shows location 1, which is done during the dry season, and this is the wet season. And here, even though it's not visible, the factor of safety is around 0.08. Sorry, 0.8. And during the, I'm sorry, I said the opposite one. Here it is around 1.8, and here it is around 0.8. The same thing happens for location 2. During the dry season, the factor of safety is unity, but it is below 1.5. According to some researchers and Collins, when the factor of, even though the factor of safety is above 1, if it is below 1.5, that means they are liable to slope failure during the monsoon season when the soil is fully saturated. The same thing we experience here in this case. During the wet season, the factor of safety is below unity here in this case. And this is the factor of safety shown by different methods. Most of the methods, they show factor of safety unity during the dry season and below unity during the wet season. And about the rock test, I performed the slag durability test. Actually, this is my research area, and from this my research area, I took out only this part for this presentation. And here in this, I took 5 different samples, rock samples, and I performed slag durability test. According to the IS code, we have to take the second readings, the second cycle readings for classification, but many researchers, they also use the 4th cycle, 3rd cycle, or we can proceed till the 10th cycle also. And these are the formula which I use for calculation of durability index. And these are the results. I performed the 4 cycles, and here I represent the durability classification based on Franklin and Sanjay 1972, and here we can see that most of the rocks are fall under high. If we classify the 4th cycle based on this classification, then most of the rocks will fall under medium durability. This is the durability index. This is plot between number of cycles and durability. From the study, we can say that the completion of I performed 2 wet dry cycle. So from this study, we can say that the rate of weathering increase, which reduces the strength of the soil, lowering the factor of safety and making the area more liable to slope failure. And this is practically observed with an evidence of 30.8 centimeter movement, ground movement, which is around 1 feet ground movement. Here this one, which we experienced, which we observed last year in the month of September. This is important roads connecting many laboratories and factories which are important for the Mizo people. And this is the lower part of the study area where movement occurs. And from the slag durability test, since most of the durability in the 4th cycle falls under medium, which we say from the 2nd cycle, we can conclude that the strength of the rock decreases when we expose to alternate wetting and drying conditions. So if we continue the cycle of wetting and drying, obviously we will the soil and the rock strength will decrease, which will greatly contribute in triggering the slope instability. So therefore we can say that both the soil and the rock strength is greatly affected by the seasonal changes. Thank you.
Last presenter, please.
Good afternoon, everyone. My name is S. Kiara Shakri, Department of Geography and Resource Management Research Scholar. We are not yet registered, so we haven't started our research. So my presentation is from my master dissertation, landslide hazard zonation in Aizawl city using GIS and remote sensing. And this is a location map of my study area, which is the Aizawl city. As we know that landslide is a mass movement, so I won't explain much about the landslide. So I will move forward to my results. And this is the annual rainfall, which is I've taken from 2006 to 2017. I've taken only this much because during my research, my paper was submitted on 2018, so I've taken only this much. So, and there is so many new landslide occurs in Aizawl. And even the data is already, like there is a new update after this, but I will try to explain which we already had done during this time. And this is the monthly rainfall of Aizawl city from 2006 to 2017. This is the average monthly rainfall. And as per the result and the survey which we had done during that time, the landslide mostly occurred during from May to August. Most of the landslide happens during this month. And these are the locations of the house which are affected by the landslide. We had selected only the 5 area because of the short period of time, so we selected only these 5 area. And mostly are affected, which are located in the roadside and the hill area in the Aizawl city. This one is for the loss of life and household transportation. This is from the household survey we had taken during that time. So it was recorded as loss of life, household damage, and disruption of transportation and communication in this 5 location area. Especially we all know that for those who are from Aizawl or Mizoram, like Puitang landslide had a lot of life, like 17 people were died in that area, but in the other part of the landslide area during that time there was no other loss of life. And as per the survey, house type was also very important. Like it was also has a huge impact in the landslide. Like some type and RCC, mostly RCC building was mostly damaged compared with the wooden types and the Assam type household. And these are like the slope map, which is taken from the Carta set DM from Bhuvan and generated using the ArcGIS. And as we can see that in the slope pattern, like the degree is too small. So it is divided into like 7 categories. So as we can see, the green one is the low slope degree, and the red one is a high slope degree. Yes, I will go over, and these are the geomorphology maps of the Aizawl city. And the geomorphology of the Aizawl city is we had divided only into 4 categories. And these geomorphology maps, the slope map, and these are like the geology maps, and these are like land use and cover. All these factors are influencing the landslide from where we had the research. And here is the landslide hazard zonation maps of Aizawl city. We had divided into the 5 categories, like 5 classes. Like the green one is like the low, low region, and there is the very low region, and the yellow one is the low, and the brown color is moderate, and there is purple one is the high region, and there is very high region is in the red one. So according to the research, most of the landslide occurs in these high regions, and they are very high regions. And these are like the conclusions. So according to the research, like we had survey that like we have observed that like geophysical factors plays an important role in the occurrence of landslide. And for the further development, for the further development, we have to look after about the location, which is very prone to landslide. So that's all.
Thank you all for very good presentations. Actually, it is much beyond my expectation. Particularly, I was very much fascinated with the landslides presentations. So much expertise is there in this university. So they are very fascinating. And of course, with the new broadband instruments, good work has been done. And one interesting paper was there on temperature and climate related topic. That was also fascinating to me. I think all of you have done very well. And definitely, since there is some marking, so everyone cannot get the highest score. So only one will get the highest score. So that will be assessed afterwards. But at the first hand, I can say that I am very much impressed with the presentations, and particularly for the students. I think as I understand, one undergraduate student has presented. So she also learns from this seminar how to, next time how she can further improve. She has done very good, but already I think co-chairman advised her that you see when you present something, your number of slides should be accordingly, selected. So that part, I think that student was giving more time on the introduction part, and she could not speak on her actual work on the building design. So that's fine, because she is just an undergraduate student, and this is maybe her first presentation. So that way, I think she has done very well. Very good slides she prepared. Unfortunately, she could not present all the slides. She had to wind up. But otherwise, I think all presenter has presented their all the slides and very well presented. I tell you one thing. In my experience, when I was doing my PhD study abroad, I was telling in the morning to Professor Pavi that this type of seminar or presentation by the student is very much essential, because they, in fact, when I was in Tokyo University, every weekend there was, Friday, at the end of the office hours, means say at 4 or something like that, there is to be a presentation. And in my university, all the research scholars, every 6 months they are going to give some presentation. How you are doing? That's what one, the faculty they want to see, and they want to give some comments. So I think all of you are either MTech students, master students, or except one, I think one undergraduate students, all are, I think, PhD scholars. So particularly the PhD scholars presentation was so good. It was really good. And the way some people, some presenter, not only their slide is good, work is good, content is good, but the flow, like a professional lecturer, they are giving the presentation. So I am really so impressed with your all presentations. So thank you very much. And the result of the, naturally, as I said, all cannot be the highest mark scorer. Only one person or two, first, second, third, whatever they have decided to judge us, that will be assessed afterwards. So thank you very much for a very good presentation. Thank you.
Well, dear friends, we are running behind our time schedule, so let's have our lunch and then be seated here at 2 o'clock, so that we could have the valedictory program winded up by 3 o'clock. At 2, starting from 2, we have another presentation. Most probably 6 technical sessions, 6 presentations. And I have totally forgotten to give this token of love to my former teacher, Dr. Saitoma.
Yes.
This one. Well, yeah, another, just 1 more minute. Presentation, may I request the organizing secretary, Dr. Ladin Puya, to present presentation certificate to Puri Saikia.
Yes, please. Yes.
And Hirak Joyti Saharia. Dr. Saikyo, sir, please. Okay. Dr. Madina.
The first presenter, I just hand over the certificate to him. You please come forward and have a picture. That would be nice.
Lalo, Sana. Next, Laram Ruati. Lal Ming Sangi. Sí, esta la haremos que tuya.
Lunch break.
Okay. Can chairperson tell you that again? Let's our chairpersons and keynote speakers move first for the lunch. And then,
Thank you. So the last technical session 4. I think we can start now. We have 7 presentations in this session. Let me straight away call the first one. Joy Meon Joy Burman.
What is the time given?
You have 10 minutes for your presentation, like the previous one, 8 minutes. And
I will try to set
yeah.
within the time.
오늘 또 듀티 가면 듀티 가면 오늘 한 얘기
So,
Two. Okay. Okay. So namaskar, myself Janmanja Burman. I am the research scholar of Department of Geography and Research Management. Today I am going to present on my topic Forest Fire Susceptibility Generation of Mizoram using Geographical Information System, a comparative analysis of bivariate models. So as we know, Mizoram is very rich in forest cover. As per the percentage of the total land area, Mizoram is highest among other Indian states. So here is the introduction. According to the Indian States Forest Service Report 2015, the state has the 88.93% of total geographical area is forest cover. And if we look the inter-district disparities, it is the Champai district highest maximum dense forest area, that is 60 square kilometer, then Mamit and Aizol. And if we go the percentage of total according to the geographical land area, then it is Longklai district has the maximum forest cover area, that is 91.40%, and minimum is Champai district, that is 83.92, and the diversity of forest type is also very looking according to that report, Indian State Forest Report 2015, that is Mizoram has an area of 138 square kilometer very dense forest, and subsequently 5,858 square kilometer of moderately dense forest, and 12,752 square kilometer of open forest. Then so we know as parallel it is reached to forest cover, and forest fire vulnerability is also looking at here. Aizol and Lungnai district is among 29 forest most fire prone district in India as per the report of Down to Earth newspaper, and Global Forest Watch has reported 1604 fire alert in Mizoram in 2021. So it is noted what is the causes of such huge forest fire. So as looking, it is the uncontrolled traditional jhum farming is the most important causes for forest fire. So it is the background motivation of my study, and the table is show the different natural hazard that is happened during the 2013 to 2020, and forest fire is ranked second as per the impact of human loss, life loss, and this table is collected from the State Disaster Management Plan Report 2021. And here it is the second one I have searched in Google Scholar using the keyword Mizoram and forest fire, but here is no suspected forest fire suspect. That is the primary blueprint for further study. This is vulnerability study and risk analysis, and here it is the State Disaster Management page. They also using only forest fire location, no suspected map is existing in their plan. So I have using that in the study I have taken an initiative to prepare some forest fire suspected map using different bivariate models, because I am it is the first time, so we have to know which method has the most accurate. So we have to compare about this. We don't know, we have not any pre-existing literature, so we have to compare first. Then objective, I have taken only one objective for the study, that is preparation of forest fire susceptibility generation using bivariate models. And then about the study area, my study is extended between the longitudinal extension 92 degree 15 minutes east to 93 degree 26 degree east, and latitudinal extension is 21 degree 57 north to 24 degree 57 north, and area is 21120.71 square kilometer. And as in case of climate, it is characterized CW type, that is monsoon type of climate as per Köppen classification, and temperature ranges between 5.7 degree centigrade to 30.3 degree centigrade maximum as per the 2017 record, and rainfall is 2712.30 millimeter as per 2017 record. That information was collected from State Disaster Management Plan 2021. And in case of physiography, it is divided three physiographical unit. That first one is northeastern highland, and here the elevation is above more than 1200 meters, and central zone characterizes hilly tract with lowland valleys, and west southeastern belt is also low-lying hills and valleys. Here it is the thematic representation of my study area. First one is the northeast. First one is the northeast India within the India, and second is Mizoram within the northeast India, and here it is the brief about Mizoram along with slope distribution, training and testing, forest fire locations, and road and river networks. So here is my database. I have used 12 conditioning factor to prepare the landslide suspected images from the different data sources. Here it is my data sources I have used for the current study. So here it is my thematic distribution of slope and aspect, and the red boxes show the as per the inventory analysis of forest fire. That is, I have collected the inventory from the, I have shown the State Disaster Management Plan. I have collected the inventory from these sources, and between 11 to 20 degree slope is the high prone to forest fire, and similarly the above 40 is less prone to forest fire, and similarly in X aspect this group is most prone to forest fire, and it is the lowest group. And then slope classes and LUC, I am not going to details. Red everywhere, red is high and green is low, and second in LUC, green vegetation is maximum prone to forest fire, and water bodies is less prone to forest fire. And then NDVI, in case of NDVI, it is sparse vegetation cover, it is very much prone to forest fire, and less is water body. And then MDWI, that is normalized, motivate normalized different water index. Similar distance to settlement, in case of distance to settlement, the distance from settlement beyond the 4,000 meters, it is very prone to forest fire, and less in within 1 kilometers. And but it is opposite in case of roads. And it is low between 3 to 4 kilometers. And temperature, in case of temperature, the lowest temperature is Tmax, that is maximum temperature, maximum temperature between 2011 to 2020. A minimum temperature has a maximum chance of forest fire, and then it is the lowest class group I have classified. And then similarly, and wet day, where it is the minimum wet day, that is average 8.25 to 8.75, it is a high prone to forest fire. And similarly that, and where is the table calculation, I have used 3 bivariate models. First one is frequency ratio, second one is evidential belief function, and then lastly index of entropy model to prepare the forest fire susceptibility map. For the first is due to the space, I have not put all the things, and here I use the frequency ratio using occurrence ratio divided by area ratio, and finally I have integrated all the thematic condition as FSI is equal to FR of summation of FR. Then calculation of evidential belief function, I have used here the 2 equation. We can go through, there are 4 function, that is degree of Bell, that is here Bell function, and this degree of disbelief, degree of uncertainty, and degree of possibility. All are the function derived from Bayesian generalized method, and I have used the first for the lambda TP is TPEIJ, that is called ratio plus, and from this equation we can derive the Bell function. Here it is the description about the all symbol and short form. And secondly, thirdly, I have calculated the index of entropy model Pij, that is equal to m divided by n. That is also similar to equation frequency ratio. M is the occurrence ratio and n is the ratio of total area. And then subsequently last one equation YIOE is equal to summation of z divided by mi into c into wj I have used for suspectability map. Then here it is the final output of my study. First one is prepared by frequency ratio method, and second was by evidential belief function, and C is from index of entropy model. I have classified for the better understanding in 5 classes using the quantum classification system that is inbuilt in QGIS or ArcGIS software, any GIS software. And then it is the areal distribution of different class group by using different models. I am not going to details. Here is the red boxes are maximum and minimum area. Then it is the model accuracy test. I have used the 2 curves, that is one is success rate curve and one is predicted rate curve. First one is the graphical representation. It is clear that evidential belief function has the maximum prediction accuracy for the success rate curve. It is 0.621, and then predicted rate curve also reveal the same model, same result, that is 0.646. It is also high in case of predictive rate curve. And then I am not include any conclusion in presentation. I can conclude myself also according to based on the study. So we can use the suspective mode prepared by forest evidential belief function for future studies for especially forest fire risk analysis, and this work will be useful for the future any kind of ecological planning and roads construction, especially for when we are choosing a land for zoom cultivation. And then lastly, I want to thank you everyone to me.
Also, the Northeast India was severely rocked by an earthquake, of great earthquake, magnitude 8.1, and this is the 925 years of that earthquake. 1897, that earthquake occurred in June 12, 1897. And we are also organizing one workshop from our IIT ISM association at Calcutta on this occasion, where we are also trying to get civil engineers, geologists, geophysicists, mining engineers, petroleum engineers, because mining industry also cause anthropogenic seismicity, which I could not or did not cover here because the time schedule was so tight. How the anthropogenic activity causes earthquakes, and sometimes they are not only rock falls, but also sometimes they cause quite well-felt earthquakes in many mines. So how to handle those situations, the mining planning, development, management, because for production they go for blasting. So that is one aspect. The other aspect is also in the energy sector is that oil production. Oil production also involves some induced seismicity. In producing oils, what we do, due to natural pressure, you may recover some 20-30% oil, but then to make it more productive, we inject water or gas or sand into the formations so that the formation get fractured and oil flush to the well and you pump it out. So that is secondary production. They call it EOR, early oil recovery. So that also causes induced seismicity, and we can monitor that. Again, by micro-earthquake network actually can do a lot of things. It can do really miracles. Even in the oil exploration, suppose in a inaccessible site, tea gardens or deep forest or very high hilltop, where you cannot do the seismic blasting for oil exploration, you can take help of the micro-earthquake network. Once you go and put the stations, that's all. It is not like seismic, explosion. It is not going to disturb the village or disturb the nature. So you just put the stations and make some 6-7 months survey, record the micro-earthquakes, image the whole structure and see where is the oil reservoir. So that aspect also, again, I naturally could not cover here. So that is another aspect. The other aspect, Chairman sir already mentioned about the reservoir-induced seismicity. Nowadays it is termed as reservoir-triggered seismicity. In fact, Chairman sir very correctly says that in such a gigantic plate movement and the reservoir, such a in that comparison, such a small reservoir water cannot put that stress for earthquake. So then how the reservoir trigger seismicity is happening? It is happening, we have studied both Koyna and Aswan reservoir. It is all tectonic earthquake due to plate tectonic stresses, but the reservoir water, if it percolates to the ground, underground, through the fault structure, then the earthquake gets, you can say, gets triggered due to this liquid percolation with the fault. So that you can say enhance the time, means which was to happen say 1 month before, 1 month after that happens due to the percolation of the liquid that accentuates the failure. And that happens only in the strike-slip faulting region, where there is now you more or less you understood the different types of faulting happens in the earth crust due to tectonic movement and all. So in a strike-slip situation, the reservoir water, it percolates into the fault zone, and it may trigger some small seismic activity, but that is a tectonic activity. Only the water percolation accentuates the failure. But in a thrust faulting regime, say in the Himalaya, it is other way round. Rather, earthquakes are reduced. There is a stress, more circuit is there. You will see that only in the strike-slip region, the reservoir trigger seismicity occurs, but in the thrust faulting regime, the reservoir seismicity does not happen. It rather delays the earthquakes which was to happen in that area, it delays it. You will see in the Himalaya, the Teri Dam, there are other problems, ecological problems, environmental problems. That is different issues, different problems. But in the Himalaya, if the dam is made, the reservoir load will produce a large earthquake. This is not correct. And I am so glad to, with the remarks of Professor Srivastava here, that he is not a seismologist, but he told that a small reservoir with respect to its stress, vertical stress with respect to the plate movement is nothing to really generate large earthquake. So, but it triggers in a strike slave regions by, as I said, by percolation of water. It also happens in Aswan Dam in Egypt. So this is about man-made earthquakes, anthropogenic earthquakes, which we did not cover in the technical session, but just I took this opportunity to tell you something on this aspect when Chairman sir already pointed out about the Koina earthquake. Then about the presentation or about the seminar, I am really very pleased and very happy, very glad actually, not only from the organizing point of view, but also from the audience, particularly as already someone mentioned, that diversity. So many departments have attended these disciplines, they have attended this seminar, and the hall was more or less full all the time, and everyone was attentive, that I have noticed. And they have tried as much as they can understand, because everybody is not from geophysics or seismology, but even then, of course, I tried to make it as popular as possible so that I knew the audience from geography, geology, geophysics, and civil engineering department. So accordingly, I tried. I didn't go much, technical depth, but the general knowledge about these earthquakes, I tried to convey, dissipate to this forum. So, and Chairman sir also in the lunch time, or in the morning session, he told me that why you get so much energy, how you get so much energy at this age. Yes, I'm running 78 now, but when I speak like a young man. I get tremendous energy because that is in my blood. It is so I enjoy it. When you love your work, then energy is there. If you do not love your work, you have no energy. So love is power, love is energy. In Einstein's language, love is light. Who gives love, he is delighted, and who receives love, he is also delighted. Love is gravity, love is attraction, love is power. So if you love your work, work is worship. That is why it said work is worship. If you love your work, I think one of our young geophysicists, he expressed one thing which is really touched me. He says that he has observed some, publications which are a bit, according to him, in very rude language. I am telling the rude language. Cooked. Many publications are cooked data or cooked things, and they try to match with the previous thing or whatever. I think very good point he has raised. I want to elaborate on this point. Suppose you get some negative results of your investigations. That is an information. You don't have to, cook that data or cook that result to, match it with the others. You say, I didn't get it. I can't explain. It is not understood why such, results has come. It is not well understood. Simply, your work should be always transparent. Your writing should be always transparent. Which you don't understand, don't make copy and paste, and don't try to match with other publications or other people's work. You be honest to your work, and you say that negative result is also an information, and you say that this result has come in like this, and it is not well understood. So that is also an information. So always love your work and be honest with your work. That will take you to karmannodikarastu ma phaleshu kadachana. Possibly I have done some justice to my work in my young age, and that has brought me even today here at this age. So কর্মেই অধিকার ফলে নয়. These lessons I got from my father in my childhood, and it is true in my life experience. If you love your work, if you believe in that karma, the fall will come, the result will come. Then other aspect, I was really fascinated with the students' presentation. That is a very good program has been made in this seminar. One day invited lectures and one day students' presentation. This is a very good idea. I really highly appreciate it. And to be very frank, when I was a student like you, I never could present like this. So you have done very well. Your presentation, your work, all have done very, very good. And no one has got, I think in my marking, no one has got less than 70–80%. So everybody has done so well. So I am very impressed with the particularly the students' presentation, and this very good program that has been kept by the organizing committee. And this is a sort of training also for the young students to present in the international forum. This is a starting point. You first start at this level and you improve yourself. So I think these few points I remember, and as Chairman has said that how was the food, how was the organization, I think in one word it was fantastic. I am living in the very good guest house here, wonderful. The first fascination is that, almost 24 hours, I think now it's high time, I must end it. Almost 24 hours there is some bird chirping in this guest house, a beautiful like music. I sleep well with the birds chirping, I wake up well with the birds chirping. It's a beautiful campus, and guest house cooking, guest house food is really fantastic. And here in the lunch, both the time, yesterday, today, very high quality lunch, and everything is so good, very well organized. And big hand to our organizers, to our convener, to our co-convener, and to everybody here who are in the organizing committee. Thank you very much. Yes, sir. Thank you.
Thank you so much, sir. As you rightly said that, a scholar is never old. He is always young. A great scholar. You are great scholar. So give him. And regarding also, he told that love your work. So we call it love is God also. Love is God. So if you love God or God love you, then work will also be very good. And we also call that Parameshwar Prem. Parameshwar Prem in Hindi. So God is also love, God is work, and this love is everything. So love your work and love yourself. And regarding also this, we have now, because it is all your destiny. Those have presented and those have not presented. Completely dependent on the destiny. So those who could not present, so we are not going to ask them to present. Now we are closing here. This is now closing ceremony. Anyway, best wishes for all those who have presented and those did not present also. For them more best wishes. Okay. And regarding this, we have some Best Presenters Award. As Professor Kayal already stated that not only 60, 70, you are all are in between 99 and 100. So 99.1, 99.9 and like this. So out of this 1.1, 0.2, 0.3 or 0.1 rather, we have made some these results regarding the best presenters award, and I will call upon whom? Who will give present best?
Sir, if they are ready, let them have a chance.
You won't?
No, the four are ready for presentation.
4 more presentations.
No, you are the coordinator. If you say, we don't have any problem. So because if you want and they want also, for me no problem.
Sir, let them present.
Okay. Okay, so there are how many of you want to present now here at one?
6 of them are still
Hello, member. Shit, look at the hands on. Hello.
So just try to focus on what you think is important and try to cover within 5 minutes.
Okay. Okay, good afternoon everyone. My name is Laram Heta and today my presentation is on landslide hazard zonation mapping with the help of GIS technique, a case study from Champhai and Khobung block in Champhai district. I'll just skip the introduction part. And here's my objective to identify and delineate unstable hazard prone areas by classifying the study area into different hazard zones and to calculate the area of its zones. Here's my study area, just location of map of Mizoram and location of Champhai. Here's the main study area, Khobung block and Champhai block. The grammar of this study is based on is done with the help of ArcGIS software, and there are several causative factors, but we are taking these 5 causative factors only: landslide, land use, land cover, relative relief, slope morphology, hydrological conditions, and road map. First factor, land use, land cover. We use Landsat 8 image, and here are the metadata of this image downloaded from USGS Art Explorer. And for the land use, land cover was assembled into 4 groups in this area of interest, of our interest: settlement, agriculture, thick forest, and moderately thick forest. These are just the band number of of Landsat 8 data. In next slide, we will see the importance of this band number. By combining those band number here, here 4 represent red color, 3 represents green color, 2 represents blue color, RGB. So by combining those bands, we can extract new information. Green represents healthy vegetation, brown color represents unhealthy vegetation, white and gray is settlement, and dark and blue means water body. Similarly, if we make another combination like 543, the combination is called color infrared. If we make the combination as 764, the combination is called short wave infrared and give another information. And here is our prepared land use, land cover. Here, if we look at the legend, thick forest represented by dark green, moderately thick forest represented by light green, settlement gray, and agricultural area by yellow color. This is Champhai block and Khobung block. And for relative relief, the relative relief is categorized into 3 different zones, such as low, medium, and high hazard zone. And for this relative relief map, we use the digital elevation model downloaded from USGS Art Explorer again. And here is our final relative relief map. If we look at the legend again, if we look at the legend again, here 0 to 100 meter low hazard is class S low hazard, and if the elevation is greater than 300 meter, it is class S high hazard. And slope also here is here the angle of slope. I have written here. If the angle of slope is greater than 45 degrees, then it is considered as very high risk. Similarly, if the angle of slope is less than 15 degrees, then there is no risk at all and represented as very mild slope. And here is our final slope map. And if we look at the legend, I don't know whether you can see or not. I think you understand from the table here itself. So here is the slope map. And for hydrological, we use these different tools in ArcGIS software. These are different tools, the steps we have to be done in order to get our stream features map. So the final stream features map we prepared is showing here in this slide. Stream features map of Sampai block and Kobung block. And here, this roadmap is taken into consideration because landslide is likely to happen along the roads due to cut slopes. This roadmap is taken from Geological Survey of India. And for our final output hazard zonation, weighted overlay tool was used, and here the weightage is given to each factors. And finally, the area of each classes is calculated using the tool called zonal geometry as table. The output map was classified into 5 classes, such as very high hazard zone, moderate hazard zone, low hazard zone, very low hazard zone. And here is our final output map. Here is if you look at the legend, very high hazard zone is represented by red color, and high hazard zone by orange, moderate hazard zone by yellow, low hazard zone, very low hazard zone. And this is landslide hazard map of Sampai block and Kobung block. And here we calculate the area of each zone, of each classes. Very high hazard zone cover 42.81 kilometers square. Likewise, in Kobung, very high hazard zone covers an area of 26.84 kilometers square. And this is our result. Thank you.
Hello. Okay. Hello and good afternoon, everyone. So my name is Lerin Chana, and my topic will be mapping vulnerability of Kursan rehabilitation colony. Okay. So this is one of my work in my master, during my master. So it doesn't come. Oh. This is the location of Kursan rehabilitation colony in Chandigarh. So this is the slum colony, like the slum colony. So the colony was rehabilitated by the government slum dweller in 2010. And there is a 9-block building with 4 storage and 576 households in the colony. So these are the study area. So this is the pattern of the building. So this is the side view of the colony. So let's see some component of the colony. This is the caste. So the SC is the majority, and the religion, the Hindu is the Hindu religion is the majority there, and literacy is like 16% of the population is illiterate. Okay, this is the age group. So the majority is 10 to 20 years of age, and then this is the number of family member. So 5 members of the family is the majority of the family. So this is the family income. So majority is like they are having income per month in like 5,000 to 8,000. So this is the objectives, and then this is the methodology. So we have to skip it. So this is the the parameter of the vulnerability. So we are going to assess mapping their vulnerability. So first we are going to take the physical vulnerability. Under the physical vulnerability, we take some parameters like density of the room, locations of the LPG go down, and location of reserve forest, locations of heap of garbage. All those 4 parameters are taken, and then they are giving some characteristic, and this is the physical vulnerability map. So as you can see that there is 3 pink building, 3 block. They were the highest one, and the orange one are the moderate, and the blue one are the low vulnerability. So this is, oh my, sorry, it was not supposed to be like this. So this is so after that we went after physical, so social vulnerability. We are going to assess the illiteracy and vulnerable group. Vulnerable group, it includes like old age, like 60 years of age, above 60 years of age, and below 60 years of age, and person with disabled and pregnant women were included in this vulnerable group. And the household with a woman headed. Apparently there are like widow family, so they are more vulnerable to disaster when the disaster come. So this is the social vulnerability, literacy, vulnerable group, women headed. So when we mix up, it came up like this. So it seems like that the pink one are, yes, like before, the pink one are the most vulnerable, and then the orange one is moderate, and the blue one are the lowest. So then after that, economic vulnerability. So for assessing the economic vulnerability, we have a parameter like number of casual laborers in the colony. So household with no transport vehicle availability, household with an employment problem. So with these 3, it comes out like this, and then this is the map. So it's in this map, the number 6, block number 6 is the highest vulnerable, and the other, the blue, are the same as before. So this is when we combine all the physical, social, and economic vulnerability, it came out like this as a table. So, and this is the final distribution and level of vulnerability map. So it seems like that only block number 6 is highly vulnerable, and then all the other blues are in low vulnerable, and number 1 and 3 are in block number 1 and 3 are in moderate vulnerable. So that's it. So the most vulnerable block in the colony is highlighted with the pink color before, and then it is number 6. So okay, that's it. Thank you.
Hello. Good afternoon, everyone. My name is Kayal, and today I will present one of the reports I done my master's, and which is Odisha Cyclone Preparedness and Mitigation Planning. I will not describe this one. I will move to disaster profile. Due to subtropical organization, Odisha is prone to total cyclones, storm surge, tsunamis, floods, and earthquakes. 40 out of 100 local bodies of the urban state license earthquake zone 3, which is moderate zone. And this is disaster assessment, state fire, chemical, industrial disaster, and vector-borne disease epidemics. and all this is best steps. Cyclone management system in Odisha. The ODP was initiated started in the 1995 Indian Red Cross Society and the Odisha State Plans. The initiative was supported financially and technically by the German government, KFW, and the German Red Cross, GRC. The program was implemented in two phases, ODP phase 1, which is 1995 to 2002. It includes construction of 23 multi-purpose shelters in 6 cyclone coastal districts of the state. And ODP phase 2. For the successful implementation of ODP phase 1, KFW and GRC extended the support for ODP phase 2 in 2003. Objective of ODP is to reduce the vulnerability of the people to cyclone, to establish a culture of disaster preparedness in order to protect the livelihood of cyclone coastal districts. Accessibility and translate district government promoting disaster preparedness. This program included the construction of 36 multi-purpose shelters for a population of 61,885 in 72 villages in most cyclone coastal districts are Balasore, Gagat, and Kempara. Cyclone risk reduction mitigation plan. The government of Odisha implemented programs in disaster-prone districts two phases from 2002 to 2008. It was supported by the government Ministry of Home Affairs and the International Development Program, UNDP sponsored the community-based disaster preparedness (CED) program was also implemented in 10 coastal districts. The overall program is sustainable reduction in disaster risk among the most disaster-prone districts. And these are the program districts table showing the program districts in detail. National Cyclone Risk Management (NCRP) was one of the review to address cyclone risk in the country, which is backed up by the World Bank. Mitigation measures are divided into the structural mitigation measures and non-structural mitigation measures. I'm going to tell is prioritize economic, social, and all other structural mitigation measures, and non-structural mitigation measures are public awareness, education, information. My finance is supported risk transfer high, even the risk transfer is insurance. Cyclone preparedness plan. Odisha State Disaster Management Authority, in association with several national and international communities, establish and create number one multi-purpose cyclone shelters. 97 multi-purpose cyclone shelters was constructed in Odisha by 2005. And another 38 multi-purpose shelters was constructed under Prime Minister's National Relief Fund, and 50 flood shelters was constructed under the Minister's Relief Fund. Buildings. In association with the Department, four welfare stations was constructed in Odisha. Then automated weather stations, AWS, association with Indian Space Resource Organization. AWS was set up in different parts of the state to generate digital data and the flood and drought forecasting. These are force unit. It consists of 5 units, and later on 5 more units was added in 5 more districts. 6 years of communication to use satellite phones. A dedicated civil very high frequency and network was introduced in most of the districts of Odisha. And satellite was provided in the 30 districts by 2009, and HM amateur radio station was one amateur radio station was constructed. What we have to know is that amateur radio station is the only communication available after 45 days after the 1999 Odisha cyclone. Conclusion. Just type finance, improving disaster preparedness, capacity has clearly paved the way of cyclone fighting by 2013, which saved many lives. From the first cyclone, the Western states has been moving hard to increase the resilience of the state, and the people by strengthening their coping capacity, by building up their confidence, and by strengthening their preparedness. Now it seems that they are prepared to face disasters of the civilian magnitude. Thank you.
Hello. Today I'm going to present as a social council. My name is Benjamin, and my supervisor is Madina, and I am the fourth semester student of CCM, and we are the first of CCM student. Go to the slide. Yeah. Yeah, okay, good. Let's go to the introduction. In my this is my second semester dissertation. I'm still doing this research also in the fourth semester, and I'm still going on. And added some data, and this is the second semester in the last year dissertation, and I'm going to present it. The reason that we choose some numerical concepts is. As you can see that including landslide flood and earthquake, human settlement are vulnerable more than compared to the other central parts of the city. And let's go to the next, and this is the criteria that I made, and all the methodology that I have applied is according to the based on National Disaster Management issue book. I copy and analyze and I copy the model of that book, and I'm going to take the recent vulnerability assessment, and I'm going to make this 3-point analysis: factor, ecological, population, and physical. On these three base analysis factor, there can be three hazards: fire, landslide, and rockfall. On base three, that I'm going to analyze these three: ecological, population, and physical. Let's go to the population. As you see, that study is 3,833 population. Based on that, male is 1,836. Male population is not vulnerable because of male are stronger in disaster community. And under age is like under 14 age, and old age is over 70 age. There are 22 and 22.81 and 8.65%, and female is 52.6%, because female are more are all vulnerable because of their agriculture. In the plain area, there is flood disaster. Most of the women are staying in the house because they are working in the house, and we are putting the all vulnerable, and the total vulnerable chance is 84.12. This result is showing that during the pandemic, during the lockdown and curfew, only adults person are all to be outside, and this illustrates that the 84.12% vulnerable chance show that Chamari population is, especially in pandemic, they are all vulnerable. This map is easy to understand. I'm not using GIS. I'm using GMX, but all exactly the same location, something, another information. So but the different amount is different. And the red that you see in the line, that are 740 and 50 years old building. Then the line is all buildings are lose strength in time. They are vulnerable in different hazards. And these are the one chances they have output. The reason that is if the entrance is small, people can stand in place. And there is a low rate of evacuation, and there is a resistance. This is also this area, like this side, the red one is the highest. The population line, some of the area like red is angle, 65. And if you go to this area, there's a red building.
but if you go to the Philippines, you are feeling like you are really here because the slope is some 6-7%. The calm. And the control did not affect just slope. They are under this part of slope category, and the high requirement is located in 100%. They are in danger. These are lens zone. This lens zone is based on the historical data and analysis of the slope and other spot verification, physical verification. These are done on 10 or 2022, and this is all these lenses are from this red and the medium, the moderate zone. This is the roll. It's all the same as the lens type, but so something between this type of hazard, but predicted the roll zone, and it's occurred on 6/22 and 2022. And this is the resilience of the roll lens that we made. We already put the function of the area and the portfolio, and this is fire resistant and the fire fixation. This is red fire point, especially some house constructed using wood. This one is also considered that this is also marked on 10 or 2022. We want that this is due to the current case. We want that they are in danger on this is day. But I don't know this is or not. But we want that the outcome is like that. Fourth house are burned out and more than 40 large property here. Also in my conclusion, we can do that all the type of survey and analysis. We prevent more damage and more disaster in our city. That's also my presentation. Thank you.
So, good afternoon, everyone. Respected chairpersons and my dear friends. So, my topic for today is post-seismic effect on cold water springs of Sikkim, Himalaya. So, the study has been carried out in 2021 with the aim to correlate seismic activity with the dying springs in Sikkim Himalayan region. Before going to the findings, I give a short brief about the springs and how seismicity play a role in this spring behavior. So generally springs are the points on the ground from where the groundwater discharges, and it is generally fed by our regional aquifer systems, or we can say groundwater. And these aquifers are generally hydraulically connected ports or geological formations. The effect of seismicity in that seismicity can create fractures or may break old fractures and disturb the aquifer geometry. So, in next, these are the great earthquakes in the Indian Himalayan region. First one is the Kutch earthquake in 2001. The study reported widespread appearance of water bodies and channels in run of Kutch, and after great earthquake in Kashmir, after Kashmir earthquake in 2005, this earthquake induced landslide, and landslide later caused flash flood in the area that destroyed many houses and many lives.
And as you can see in Nepal, we had earthquake. After the earthquake, in subsurface, there is a total disturbed total hydrological framework of the area in North Bihar. So it is follows the Sikkim earthquake of 2011 and compare the effects and compare the time data with the published data or with the previous studies collected from secondary sources. So Sikkim earthquake is a shallow earthquake with having 6.9 magnitude, and the tremors were felt till Delhi, and the main epicenter is 66 kilometers from Gangtok, the capital of Sikkim, and 70 kilometers away from the state area, which we'll see. And this is Google image showing before and after earthquake effect on the ground on the surface. So that in the above one, the land is you can see, and then in second one you can see there are various landslides induced by the earthquake after 2011 earthquake. And this is the study area. So we have selected the area in the south central part of Sikkim Himalaya, which is in the south district of Sikkim. So this is the watershed area. We have collected the data in this particular watershed, and so this is the methodology adopted for the study. So in this video, comprehensive mapping, collected household survey, people perception data, and spring inventories, water quality assessment, and data analysis and modeling. So we have collected the quality of springs also. So this is the data of 2000 to 2021, and we noted that there is no any changes in the quality of the water quality after the earthquake. And this is the few graphs showing the after the peak by the peak perception. And in this graph you can see in this graph 76% of the people said after 2011 earthquake in Sikkim, they said that they found changes in fluctuation in the water source. So based on this, we collected the field data, and we use GIS for topographic analysis. We created various estimating layers using SRTM data with 30 meter resolution, and created various estimating layers to correlate the primary collected data, and we found that in and around this watershed, around 50 plus springs were there, and out of which 8 to 10 springs were affected by the 2011 earthquake, and they were completely vanished after the earthquake. As a result, after this research, our findings is springs are not only affected by the climate change, and there is a certain amount of by the earthquakes. And aquifers for the reason where aquifers in the study area experience compression in zones and extension. In compression zones, in compression areas where the surface had compressed, it reduces the porosity and permeability, and where the extension happened, the surface area, the land stretched, its porosity and permeability had decreased in that area. So we, based on the findings, proposed the conceptual layout, a 3D model, which you can see as you can see before and after earthquake pictures in this image. So in this we can see compression zones and extension zones, where in compression zones the springs were dried, and in extension zones the new springs are emerged in the area. So this thank you. Sir, in few published data, it has done 66, and I have seen in your previous presentation that it has done 50 kilometers. Sure. 20 kilometers. Yeah. Sir. Yeah. Yeah. Deeper. Sir. Yes. Yes. Yeah. Sir. Yes. Hello.
Good afternoon, respected chair, both chairs and my teachers and my dear fellow researchers. I am Kayal. I am going to present research of natural hazard in residential environment, a case study of rental housing in Aizo. I am the last presenter, and all of the present in this seminar are from the objective approach. Since a paradigm shift was taken from quantitative revolution to behavior or subjective like that, you cannot ignore or neglect the subjective approach even in disaster management also. So my study is based on the subjective approach, and the perception, which is the perception is subjective, and which means that the vulnerability or the objective things we perceive is different from person to person, depends on some economic, cultural, or objective things. And due to the limitation of time, I can go to the important parts. And the methodology, I take 500 steps from 7 local councils, and these are the variables I use. Risk perception is studied in India through broad approach, realistic approach and constructivist approach. But here I studied under the satisfaction approach. We collect data, satisfaction data, what's the residential environment with natural hazards like slide, earthquakes, and stopping regarding the site building. That's Likert 5.0 scales use very from 1 very satisfied to number 5 very satisfied, and number 3 is neutral. And you can skip this. This is landslide susceptibility map of Aizo city, and this one is map of Aizo city. With these two, you can find out the relation between the actual condition and the satisfaction level. And from you see that the XY coordinates, we gather the XY data of the household regarding the landslide susceptibility zones and slope. This is the result, objective number 1, levels of the satisfaction. Sorry, this one is area, zone and degree, and the house percentage. And this is the indicators which are taken. And this is the findings. This is the objective number 1. As you can see, the overall satisfaction rate is 3.998, put at slightly satisfied. And here you see moderate high in every variables outside, including slide buildings, top degrees are people's
satisfaction can be put under moderate high. And this is the objective number 2, relationship between natural hazard, disaster, and resident satisfaction. This is the satisfaction rate, the rate of satisfaction and the actual conditions of the natural hazards like as you can see here, only slope degree are significant to the satisfaction. But their relationship is inversely, which means that the satisfaction the slope degree is high when the household who live in high slope degree are less satisfied in terms of earthquake, hillside, building slope. But landslide susceptibility, there is a significant relationship between landslide susceptibility and the natural hazard. And this is resilience index. From this index, we can analyze and find out the factors which will influence the resilience satisfaction. By using resilience satisfaction index, we integrated 5 variables in one index, and then the relationship was calculated by using Pearson's correlation. And here you see age of the respondents and household income and building of the age and building type and slope are related with the satisfaction index. And the others are statistically insignificant. And for the deciding factor of plantings, here you can see slope and safety from disasters are the 11th and 12th position for deciding factors of plantings, which means from the result, landslide susceptibility and the satisfaction is correlated, which means that our awareness on risk of perception only related with slope, which means that our awareness risk, we have to make awareness the actual conditions, and because awareness and education preparedness can reduce the vulnerability of the hazard. That's all I can present. Thank you.
very nicely. And sometimes what you want is very time is not like so. We also hold anyway, you know that way to say my mind on the top space is very less. So if you go everywhere also, space is only one down lots of space. Even the time is one and you will cover one. So the top you have space. Anyway, so the only one it goes to lal sanga. Yes. Next slide. And with this is for today. Now I like all on the Sangha for what out of things.
Respected Chairman for the thank you, sir. Ladies and gentlemen, very short notices. It's now pretty late. First of all, a very good late afternoon to you all. Before getting started, to the board of my sincere apology to the public relations cell of Zura Visibility for I have missed out our name during the development program. You know, the public relations cell amidst the several ongoing seminars these days, they have even as their priority in video coverage from Alpha to Omega. I'm sure they are very much well aware about the importance of our topic that we are given priority, and I would like to thank them. Next, to our participants, Professor Kayal and Professor Saya. It has been your efforts and your services, your lectures, speech, which have made this seminar successful. And on listening to your lectures, I am convinced that there are none better than our two invited speakers to deliver such talk on the topic related to earthquake protection for us in Northeast Asia. So I really appreciate the work and the lectures given. And secondly, to all the scholars who have presented their excellent papers, you know, your presentations were very informative and you have calculated lots of knowledge. Even though I was moving in and out of the hall, whenever possible, I at least from the door, just outside the door, I listened to your lectures, and I really appreciate the knowledge you have been trying on since the beginning of your research work. And I hope that through time and space you would improve in trying to find out new things for the betterment of society as well as for the environment. And to all the I should say the faculty from the different departments like Professor Kayal is now with us, and Professor V.P. Sati. I would like to mention point out once again that the geography faculty, they have been like other, they have been receiving their support and encouragement right from the beginning till today. And I would like to convey our gratitude on behalf of the Center for Disaster Management, and to all the research scholars, the students who have been working so hard in Forget about the classroom, the seminar hall. They have been very busy connecting our lunch pack, our refreshment, trying their level best to give satisfaction to the participants. They did not want to have ourselves get hungry, and we want to feed us well as well. So I appreciate the work by the students as well. So at the same time, I feel sorry that I'm happy for that. I feel that we are going to have a very wonderful following up program when I guest house to say goodbye to our respected speaker, Professor Kayal, for the faculty of Center for Disaster Management and Emergency Management. All the teachers are likely present to say goodbye to Professor Kayal. Not only that, there is research scholars of the CCM as well as the students are also likely there. I'm sorry that we have faced some constraints. We invited all the students and scholars of the department. Really sorry for that. Next time, we shall have your names included in whatever party, whether it's dinner party or just party. Your name is included next time. So with that, I conclude my vote of thanks. Thank you so much.